of various industrial In this session, the experts of various industrial and academic fields will put forward the fundamentals of career development. The lineup would be as follows: Career Industry by Mr. Bhupesh Agrawal, sir. Second, Career in Academia by Dr. Biplab Sikdar, Dr. Anurag Srivastava. Third would be Students and Young Professional Development by Dr. Rajeev Kumar Singh, Mr. Prasanna Rajgopal, Mr. Anant Kumar Singh, and Dr. Akshay Kumar Rathore. For the first session in Career in Industry, I request Mr. Bhupesh Agrawal, sir, who is the Group Manager for John Deere India, to convey his experience and expertise. So,
Divya, can you introduce first? I mean,
yes,
the profile is with you. Yeah, please introduce first.
He has done his Masters of Technology from Indian Institute of Technology, Varanasi. He's done his management course in System Design and Management from MIT Sloan School of Management. He has headed about 21 plus teams in various fields. He has led about 21 plus cross-functional electrification group engaged in global product development programs, engineering lead and architecture for advanced electrification demonstration vehicle for global program line, and manage global compact and utility tractor strategic electrification portfolio. Now I request Mr. Bhupesh Agrawal to enlighten us with this enriching session. So,
thank you, Divya. Thanks for your kind words. And thanks, Dr. Arun, for having me here to get an opportunity to talk to young engineers, would-be engineers, and share some of my experiences. Keep it more informal in terms of sharing some of my perspectives, some of my industrial perspective from off-highway. I'll start first with talking and just give you a glimpse about me as I'm talking to you, just to give my insights what I go through my career. So if you look at my career perspective, it start from Indian Space Research. After my master's, I get into Indian Space Research. Very different organization from a research perspective. I was with the inertial system units, working on some of the forward-looking accelerometers and gyroscope development. And being in ISRO for 2 years, opened up my views towards organizational perspective, what we learned, how we take those learnings to the organizational level, implementation level. ISRO was an upfront organization in driving that. After my 2 year stint with ISRO, I moved to Pune with Cummins Research, another global leaders in terms of engines as an OEM. And there I spent close to around 1.5 years looking into the engine development, which was at that time at the pinnacle of the technology. Some of the most complex advanced technologies, controls get into the engines. And that's where I spent around my 1.5 year. And as you can see in my initial career, there looks to be 2 companies in 3 years, 4 years. And then I get into John Deere, which is the global leader for off-highway equipments, including constructions, agriculture, turf. And that's where I am been for 16 years. So around organizational journey, it takes some steps to really find the place where you want to go deeper and develop your career. Now, moving in terms of domain, how I look at my domain. When I look at from a domain perspective, I started like many of the young engineers around the system simulation aspects, where I was in the ISRO and Cummins, John Deere were looking into structural, thermostructural, multi-physics aspect. And that's give me an analytical aspect. When I look into any problem standard, any product development, the initial years in virtual validation, and I'll come to you that how simulation is one of the critical vertical as we get into industrial development. This helps me to understand the physics, understand the analytical aspect of the product development better as we get into the market. That initial phases of virtual validation, which was very broad, as I mentioned in the ISRO, Cummins, John Deere initial phase helped me to slowly shift towards what we call the electric drive journey for me. Started in 2008 when the John Deere have started looking into electrification. And few of the initial aspects were, hey, how we look into batteries, machines, system aspect of it. And that's where I get into some of the system simulation aspect of it, how we understand machines better, how we look into the system artifacts, battery modeling. And from that, my career again take a slightly jump and then move to at what we call an electric drive system level, where I was more in the product development, looking into the architectural development from a design perspective, finding the right suppliers. And that's where the industrial aspect of electrification started. As we get into the industrial aspect, it's the collaborative industry where suppliers, OEMs, different other artifacts like the test agencies, R&D agencies, all have to come together to provide the solution. And that's where I spent some time in terms of supplier interactions, getting the muse ready for the market development introduction. And at the same time, as I move into my career journey, there's another opportunity where I get my systems 1 year course with MIT. And why I'm highlighting here is the need for continuous learning. The learning never stop. What we are taking out of colleges and engineering is just get you a head start to get into the industry. When we go out of industry, electrification or electric vehicle was just a buzzword at that time. It's all learn on the job. And when you are getting into, I'll give you some insights of what's coming in the future. Those technologies, most of them you have to get on the job. And that's where continuous learning is a critical aspect of it. Part of my current career, I'm in the more on the organizational levels, working in terms of, okay, let me take this out. Management, more from a product development, talent growth, technology roadmap. And that's where I'm in the current phase of my journey. So that's about me, just to give you a perspective of from an industry, when I look at it, how I look at my 18, 20 years in this industry. Now let's talk about vehicle electrification and what are our consideration from an industry perspective. Some of this may be repetition because this is an active area and some of my colleagues, some of my other industrial experts have already given you insight about this. I'll take an attempt on automotive and then give you some flavor of off-highway, which I thought it will be very unique for you. And the perspective is to give you industries are wide industry. Automotive is one of the industrial aspect, but there are multiple aspects of industry when we talk about vehicle electrification. Now let's look at vehicle electrification. Is it new? No. In 30s, we have electric locomotive already. The complete electric vehicles in mining is in existence from 60s. It's not new. There are electrically driven big mining machines available. In 90s, we already see advent of the hybrids in the world. It's coming. It's coming. It's maturing. It's going even beyond, as I mentioned about my industries of highway. It's from automotive now spilling over in terms of development in other industries like agriculture, construction. And again, the future is again very interesting in automotive and even in off-highway industries, right? It's not even a driver. There's no driver on a machine like this. Now, a similar solution for automotive will be there where there's no driver. What we are talking about is a mechanism to do the job using electrified solutions and having no driver, or you're talking about the big machines completely electrified, which brings their own unique challenges on board. So this is a journey which is an ongoing journey and will continue for another few decades until it reaches maturity. Now, what's driving the electric vehicles? Some of this you may already be aware of, just for repeating out. If you look at from India perspective, even this series which we are currently participating, where government of India is helping connect the industries, academia with the students, there's a lot of push coming in terms of our policy guidelines. We want to get into electric vehicles because we want to reduce our dependence on foreign oil. It's a big contribution about how we look into uh, foreign oils and how much savings we can bring out if we have our own alternative source of energy. Uh, economic growth is another aspect of it. Foreign oil, if you see our per capita and the expense, it's a big part. Uh, we have look at into our national electric mobility mission plan. You're already seeing it. At least the location I am in, Pune, we can see all buses that public transport is getting electric. There are a lot of development happening in terms of public charging. So government is moving fast toward this electric mobility. And then finally, Niti Aayog's long-term policies directing that we need to get into electric around 2025, 2030 time frame. So domestic policies play a big part in why we are talking about electric vehicles. Second, around global impact, energy independence. Uh, Europe is already taking a lead around the electric journey. They want to not only independence, but they also have a very, very cautious efforts towards climate change. China, uh, I had visited China as part of IEEE program, I think a few years back, and pollution was a big thing there. It still is. It's even worse than some of our cities, but they're taking active steps in terms of how we look into growth with pollution management through electric vehicles. So in India, Delhi is another good example. Pollution is a reality now which need to be managed proactively, and electric vehicles will provide a solution around that. uh, how all the governments, including India governments, European governments, UN, providing active fundings around clean technologies. Again, the whole we see world around us, right? A lot of dependencies on oil, and that create a lot of political issues. How we create this whole dependencies on dollars, unstable regions, to bring the independence of energy through the electric vehicles. Now, some of you may argue that finally batteries come from Southeast. We don't produce it. But yeah, there are efforts around that also. ISRO and few other organizations in India also putting some efforts how we can localize some of the battery development. But it's a journey to start. And finally, the climate change. I'll not emphasize, but yes, how we are looking into the climate change. Some of this thing, positive part of it, we see in the COVID lockdown. When we don't have pollution, how we hear great stories about climate changing. But yes, it's a fact. We need to grow. We need to have industries. How we manage it effectively. Transportation, around 15% of energy comes of this whole CO2 comes from that part. Urban air pollution. It's sometime the question comes is electric vehicle. Finally, you're doing generate electricity through coal. Yeah, it's a fact. It's not that it is a completely good clean energy fully until we give shift to nuclear or solar or the hydro. But yes, it shifts the pollution out of urban thing. It takes them out to area where there's very, very minimal population. So the urban air pollution, another aspect which is driving electrification. Now we look at India ecosystem. Again, FAME 2 policy. You all of you would have get some insights about that FAME 2. I will highlight few of the things which catches my eye around this whole FAME 2 policies. We have FAME 1 policy which started with intensive incentives given to the organizations about making electric or hybrid. But the incentives are more towards, hey, you take the electric or hybrid vehicle and we will reduce the cost. And it was not too much a success. The reason being highlighted, it's private. There will be still a lot of, I'll say, socio-economic mindset changes required before electric will be accepted at a private level, where I'll go out and buy the electric. What government shifted its policies, and that's again some of other governments in world are shifting, is get into public levels. We have a huge investments around public transports, the government buses, three-wheelers, four-wheelers, commercial taxis. uh, that's where the FAME 2 again putting more focus, commercial purposes, electrification for commercial purposes. And they also realize that the charging infrastructure is the bottleneck which will not allow it to grow. So focus on charging infrastructures, public transport, commercial purposes, and then how we take it to the two-wheeler segment. Because if you go into private vehicle, one of the segment which see the exponential growth is around two-wheelers, three-wheelers. It's a need. It's an area which is sensitive to the fuel prices, currently touching 105 rupees, 110 rupees. So there's a lot of focus from government side also coming in this two-wheeler, three-wheeler segment. Again, another dimensions around Uber, Ola. As they are commercial vehicles, they are shifting towards Uber, Ola. Uh, Uber and Ola, they are also getting into their own production in a way, like huge factories, 10,000 employees, and I think one of the biggest battery factories are being produced in India, Chennai. So a lot of interesting movements happening in terms of India ecosystem, but focus is more on commercial at this point. Again, this shows some of the numbers around, and again, this is before our COVID times, but the numbers talks about how the focus is more around the buses, focus is more towards the two-wheelers, three-wheelers, or the taxis. Even in that, the take rate is not that high. We are talking in a single-digit take rates, and hopefully that in another 1 or 2 years, the take rates, especially in the buses and two-wheelers, start getting into double digit. One area which is seeing significant growth, and that is business driven growth, is the three wheelers. Delhi and many areas, the three wheelers are now shifting towards electric. I'm not sure about the Jaipur and those areas, but it's coming fast. Very soon you will see those electric three wheelers all over the road. What it brings for us as engineers, it's creating a different paradigm. It's shifting focus out of the core conventional technological challenges, which is around engines, transmissions, how we do the fuel efficiency improvements in the engines, controls better, how we look into the exhaust management, all this pollution norms, right? Bharat stage 3, 4, 5, 6, and then auxiliaries. It's shifting from there to talk about the BEVs, what we need to do about battery management, what are our sources of electric motors, power electronics. So a lot of industrial thought process is shifting out from the engines to the battery electric. And if you look at a very holistic view, I can say the technology is simplifying. Engines, developing engines is a very complex technologies. Batteries are more accessible. Once you get into electrified solution, it's a doable where you can have a mass implementation of this technology. And that's come that engines being a movable part, it has its own industries. You need the repairers, you need the 6 months overall of your vehicles, go there, replace the oil engines. Batteries take it out. If a properly designed electric vehicles or hybrid vehicles has a life period of 10, 15, 20 years, you don't need any major servicing before for many years. It's all changing how we look into our ecosystems around dealers, OEM. So other perspective which needs to be taken care as we get into India ecosystem is about how this shift from diesel gasoline engine based solutions to the battery operated solution will also impact the ecosystem. Finally, I just want to show you what's happening around India. Again, this is still very evolving size. It's a year or two back slide. So you may see some old data, pardon me for that. But you can see some of our major players, right? Tata, Ashok, Mahindra, Volvo, Eicher. All these are big players around India market, especially on the on-road electrification. And you can see depending on what they are doing, if are they doing in terms of the hybrid, or are they doing in the electric, are they doing a small vehicles or what we call automotive vehicles like car, or they are getting into specialized vehicles, or they are talking about the buses. The voltage levels, it varies all the way from 4872 volt to 900 volt, having its own industry technological complexity. As you go above 60 volt, you are no longer in a touch safe voltage. Altogether different isolations and many other technological aspects kicks in. Similarly, the battery sizing. You're talking about the use cases for a car and having a battery for that entirely different than the buses. Buses have a fixed routes. They need to have enough batteries to go out of their depot, do the complete route, have certain 10-20% extra margin, and then come back. Very defined, but very high requirements. So very different use cases. It varies all the way from the battery sizes vary all the way from initial 10-20 kilowatt to the three digit numbers around 120 300, especially in the bus segments. Now, looking into all of this, what are the key building blocks which our industry is looking in terms of the electrification? as I talk about different electrification, even in the automotive and beyond industries, you talk about the luxury vehicles like off-road vehicles for the work, but also luxury vehicles like those yash, like the luxury boats. They all are electrically driven. All these things are have a different requirements. One of the way industry look at it into the voltage range. Uh, if we are looking into a power range going beyond 20-30 kilowatt, all of the machines start getting into high voltage. And most of the recent development is pushing towards 700 volt DC, though there are also some solutions around 900 volt DCs and higher. What are the advantage of high volt DC? The lower the size of the components, more current you can manage, more power you can manage. So there is a push to manage the components at the higher voltage range, viable within the mobile electrification. Uh, the other aspect which is happening in the lower segment is around 48 volt to 60 volt. That's where the European, the mild hybrids are getting a lot of momentum. The knowledge of what is required in terms of the architecture, what it requires for component development, system isolations. This is going to be one of the key pillar in terms of understanding and get a more direct acceptance in the industry if you have already have these knowledges. The second aspect is around standards and compliance. This is very evolving area, but significant efforts being developed across the globe in terms of standardizing what is the charger connectors looks like, what are the different voltage levels, what are the safety standards applicable if you are at this voltage level versus different voltage levels, what are the different tests for the batteries we need to be carried out, what is the definition of UN 38.3 to consider the battery is safe for air transport. There are a lot of standards coming out, and getting into the knowledge of those standards again going to be critical. Finally, the building blocks. Electrification, there are many other areas, but major three verticals which define the component building blocks for electrification: machines, power electronics, and the energy storage. These three defines the component sets which drive the electrification across the board. And finally, as I says, in terms of design architecture, the simulation or effort validation of the system before we take it for development is going to be crucial for the success of the industry. Now I'm shifting the gears. I'm bringing to a different perspective. I'm from off-highway industry. I thought you guys have already got enough of automotive industry. Let's bring a very different perspective. What electrification look for an off-highway vehicle, which is not running on the highway at 100 kilometers per hour, very different profile. What you need is just a traction in automotive. You need electrification to provide the powers to the wheels and drive it. Uh, Not true for off highway. Off highway has many things which need to be looked at. Uh, this off highways are the machine which do the job. It take the material, it process it, it breaks the material, it cleans the material. Like agriculture machines, it cuts the crop, it takes the grain out of it and clean it out and move it out. If you're talking about the tractors, there is a PTO which drives other implement. So there's a lot of implement which is required, and there are specific development of provide the electric power only for implements. A very different aspect of electrification. The overall auxiliaries, and that's even getting into automotive. We call it mild hybrid or 48 volt hybrid strategies for many of the automotive, but a lot of auxiliaries on the vehicle: fan, pumps, generators, ACs, cab management. How we can take out all these loads out of the engine equation and find electrified ways to manage them more effectively at 48 volt or higher voltages. Drivetrain, it's common, it's automotive, it's in the off highway also, but yeah, drivetrain still is a focus in the off highway. And finally, how we bring the energy storage, because energy storage is all not always a requirement. We already have a machine in the industry where it's a complete electrified architecture without batteries. It's the engine generating electric and then electric being distributed across the architecture to get the value out of the overall optimized solution without having any battery on board. So how we effectively and intelligent use batteries within the architecture is another big area for off-highway industry. Uh, Going further details in terms of what it means, some of these aspects. Improve productivity. We talks about how we increase our productivity. Can we do this faster loading like this? The machine is going forward and going reverse. If you're doing a diesel engine, you have to take it forward, clutch change, getting it reverse, and then again bring. A lot of energy being wasted in going forward, reverse. Again, the operator getting fatigued. How we increase that whole thing? Can we use electrified solution? And we have already this product in market with an electrified architecture. How we use the electrification to increase the overall productivity? Fuel efficiency, how we can look into some of the aspects. Again, here where we take out, here in this case we have a sort of a inline generator which take out the power from the engine and provide all auxiliary electrification. Here we remove this torque converter, which was the major cause for the lower efficiency, and use electric to improve the fuel efficiency. uh, New product architectures. In this case, we don't have this machine in the market. Our earlier offering was around 844, and we are going into making a new machine architecture. Any industry, when it get into an architecture, you need to design the architecture around uh, suppliers for axles, supplier for transmissions, everything. Electrification provides a easy opportunity. I'll say easy in a way that you can provide a way better architectural drivers now when you are not constrained with already casting being done or a factory being set up. And that's where the new machine forms another provide an opportunity to get in electrification introduced. And finally, environmental impact. Like we are the major players in the golf industry. Some of the PGA tours, the golf management with the oil leaking into that, it's big issue. So how we remove all the oil from this machine and bring the electric motors to cut the grass is another way of looking at it, how it impacts the environmental perspective of it. uh, Getting into some of the technological aspect, and again this is just to bring you out a difference between automotive to 5A. uh, when we talk about automotives, there's a factor what we call green. We need to be environment cautious, we need to be cautious about our CO2 things and how much pollution we are doing. Yes, that's true for off-road also, but off-roads are mostly commercial vehicle. When you talk about commercial, the buyer, the stakeholder of that machine wants the output of it. He needs to look at the what is the value electrification is giving to him in terms of the dollar value, the money, which is different than automotive sometimes. Here we need to provide a clear advantage in terms of fuel, controls, performance, productivity. The duty cycles are very different. In a road, we are talking about acceleration profile. What are my peak powers of motors? Because I need to provide the motor power during the peaking, like accelerating the vehicle. And then once it get to the levels, it's more about just cruising. That's not true with a tractor. You put the implement in the field and you walking to another 1 kilometers big field, same power. If you're taking electric power, the continuous power is the more important, not the kind of peak power. So the profile changes, and that's true for different industry. If you're getting into the luxury boats, different industry, different requirements. If you're getting into automotive trucks, different requirement. So not just one requirement always suffice all industries. So be cautious about it. Similarly, I highlighted like engine starting torque. The torque profile is very different. Environment is harsh. The electric has to survive. The reliability is another aspect of how we look into our IP protections. Water ingress protection is very critical in this environment. And finally, as I says, this is very cost sensitive market, because finally we have to bring the return on this vehicle. This is a very cost sensitive market in terms of how much overall cost for the components development. All this factor goes as an input when we look into off-road technology consideration. Automotive will have a similar list which they need to consider. You go to a different industry, they have their own considerations. Now I'll quickly glance towards some of the building blocks which I thought is going to be very crucial as from college engineering to the young engineer levels where you're just entering in the industry. Some of those aspects become very crucial. I think one of the area where analytical aspect which you're bringing from colleges is going to be a deal breaker in terms of how much depth you can get into the development. In even the industries we get into these areas like looking into overall machine designs. doing some of the simulations at motor design level, looking at a system issues like fault simulations, simulating the complete architecture at a vehicle level, look into the thermal aspect of it, architectural perspective of it. Now, it's not just about analytical. We are talking about the precious metals like the neodymium magnets, which are crucial part of the internal permanent magnet motors, and they are very costly. If you have not optimized your machine, you are putting more material on the machine than required, and it's like you're talking a difference between $1,000 to $1,500. So you have to ensure that you are designing your machine motor, you're optimizing your steels, you're optimizing your magnet to the required duty cycle. And that's where you see sometimes when the automotive talks about their new launches, they talk about that, hey, this is the new machine we designed, because that's optimized for the purpose. Simulation going to be a building block which will drive some of the next phases of optimized architecture. uh, when you look into industry, and that's where some of the skill sets are required, is around the infrastructure. Each industry requires, anywhere you go into electric, it may be R&D lab or some of the research labs, you need to have a dyno facilities, you need to have a battery testing facilities, you need to have experimental labs. So infrastructure development as part of industries and collaboration with government institutes is going to be crucial for the success of electrification. And also your knowledge in this area, how you leverage your current time in the colleges to get the basic understandings about how we should look into the dyno operations, what are the key considerations, what are the battery testing considerations, we need to look into that. Getting a hands-on and understanding the different architectures, different shapes of the machine building is crucial as you get into the industry. Finally, I'll share some of my quick perspective. These are more for giving you a perspective that this is just beginning. Even we already start looking into, there are areas which we are not even looking now. But if you see forward looking, there are areas in our field of off highway, but I'm pretty much sure everywhere, the future is wild. There are areas where we are talking about big battery sizes of like 130 kilowatt hour plus 300 kilowatt electric motors fit up into a very complex movable system, and then doing operation for 5 to 6 years continuous. So very complex machines are coming in. What else coming? It's coming autonomous. It's coming in automotive. It's coming in all other industries. There's no driver. The driver become redundant. There's no need of it. The sensors, the GPS, the coordination of all the autonomous technologies with electrification technologies going to play a big role. With electrification, it also provide a platform. Now you have a architecture, you have a transmission which is easily controllable. It understands the controls way better. A very, very jump start for autonomous operations, where you can use the GPS technologies to get the real precise coordinates and use it to control and command your machines accurately in the field. So that's another area which is coming up in terms of how we look into the autonomous operation. Is it the end? No, that's coming up in terms of swarm. Do we really need one machine? Can we break it up into multiple form of machines? Can we have a series of machine operating? It's not something in future, it's already happening. I had seen few example, I think in Europe, where for some of the commercial moving trucks, they have a series of trucks following one after another, just one main driver and all others just following command for it. There's already a discussion about breaking the solutions, like instead of buses, can we have a small components, so we have multiple small swarm of the system instead of having a big solution doing all the job at a given time. So these are some of the advancements coming up in the industry, and I'm pretty much sure this also provide an exciting area for all of you to get into industry and look towards the solution, which finally the bottom line is how it impact our society, how it will impact the people who are going to use the solution. So with that, I'd like to thank you all for your patient listening. I'm now open for if you have any questions or any things you want to share with me. Thank you.
So, dear, ask your questions, please. Sir, I have one question. Basically, I mean, segment, because in India, around 80% are the two-wheelers. I mean, there's a big scope for electrification for these two-wheelers.
Right.
In India, we have two-wheelers, that is 17%. Then after that, 20% are the four-wheelers or big segment cars, or maybe the some passenger vehicles, something like that. So the motor which we are using, that is basically a low power rating motors. Okay. So on import, we are almost totally dependent upon the import. That import is especially from China. So what we can do in that area, I mean, we are trying that we could develop our indigenous motor for that segment. We are trying something in that area, but so we need your suggestions and what John Deere is doing in that field.
Thanks, Dr. Arun. It's a very interesting question, because you're right. Automotive is doing a major shift from a two-wheeler perspective. That's the biggest market for us. And interestingly, that market is also getting into different traction. There was some launches of two-wheelers, but doesn't have enough power. Those motors are too low power, 1 HP or so, so that a lot of issues that, hey, it cannot climb a hill. If you're living in Rajasthan, especially, my father was giving me this feedback that, hey, we are from Udaipur, right? So he's saying, yeah, I cannot buy that because I get feedback this machine doesn't work out in slope. And I says, no, that's not an issue. Current machines which currently launching two-wheelers will do it. They just don't give the enough power in the original versions or the pre-launches. Coming to your question about what we can do about indigenization, how we can make it in India, right? So there are two aspects of it. The technology of motor. For efficiency perspective and the compact nature perspective, some of these are PM, permanent magnet motors, right? Now with permanent magnet, there are areas with ferrous, but again, efficiency kicks in. You need to get into the right magnet selections, magnet steels, to get the right efficiency out of this motor. Because if you make it too big, then again, it will be not usable in the two-wheeler environment. PM motors provide a very good solution, but then magnet itself create dependencies on like motor being developed mostly in China and other areas. So there are two aspects of it. One is how we bring those industries itself. We can bring the semi-assembled, or we can even bring the magnets inside. Like there are already some, especially in Pune and some of the areas, there are efforts being about localized production. And that's where the volume kicks in. As we're getting into a lot of more volumes, this become our volumes are increasing. Government is providing the incentives around it. Then bringing the raw material in terms of magnetic steel, magnets, and then assemble it out India will still provide a way better solution. Now that's more what industrial way or commercial way. From a technological institute like yours and the research perspective, uh, we were exploring when the magnet become too high, we were exploring about many aspects, right? Like simple thing, neodymium magnet versus cindered magnets. Usually neodymium, but okay, cindered nobody use because the property is not very high, good at high temperature, right? When you look at closely, you realize that it's a thing. You design motors at 40 degrees C magnet, whereas usually your magnets are always 100 plus in the operational condition, right? So getting into what is the right magnet for right cost. Second is the technology like switch reluctance, which doesn't need a magnet and still provides some advantage, but it's a complex controls. Now challenge is how to control without getting into those clogging and other issues with the switch reluctance, right? And then especially in the small power segment. Usually switch reluctance become more sense when you go into high power. But yes, I'm 100% sure there are technologies like this, switch reluctance and few others, where we can avoid dependence on magnet and provide a right solution. That's what I think we should focus more and more. And also bringing the production back to India instead of importing the whole motor, how we can
Yeah.
bring the raw material, which we don't have naturally in India, and look into production out here, design out here. As I say, optimization. Those motors, most of the time you'll realize that they are not really that detail optimized to the level. optimize design here, just material from outside and production here. That's another way to look into how we can uh, increase the adaptabilities for the two-wheelers.
Because I was in a meeting long back in 2018, just a 3 year back. Ashok Leyland, Hero Electric, all the CTOs, the big short people were there. And I asked them one question that I'm working in the area of this electric vehicles, especially charger side. So can we discuss some common problem? And if you feel that academia can help, we will try our best. So they simply told that we are not doing any R&D, and we just simply purchase it from outside and assembled it. So that is something actually we need to sort out, because our government, our PM is saying that Atmanirbhar, and also we also would like to take up that kind of assignment. I mean, that we can work something, because our young minds are also present here. Around 100 people, I mean, more than 100 people are there right now in the group which are listening this talk. So I mean, we should come out with something that, yeah, something indigenous we can develop.
Exactly.
And what kind of I mean, support we can get from I mean, industry, because we are working locally with the Janus Innovations. I hope, since you are from Rajasthan, and Janus Innovations in Jaipur itself, and director is helping us like anything for each and all collaboration. He's with us. He's saying that you develop, we will ready with the industrial prototype, don't worry about that, and whatever it takes. I mean, if we can fundraise the project also, but ultimately the things should come out. So, and
Yeah, go ahead.
yeah, what exactly, I mean, what exactly we can look out from your company, or your the John Deere, or any some common or specific problem we can talk about, or we can think about, as because the students are also there, so something we can discuss like that.
You bring a very good point, Arun. As I say, especially in India, it's coming up. I'll say maybe something, we are in the initial phase. Sometimes the commercial use or the industrial way of is get the product out, right? But then that's the whole industry. I give you a perspective, right? In terms of technological depth, like simulations, what is coming in future. If everyone just focus on what's coming on next year, then we are not developing, we are not growing as a nation, right? Industries may focus as what is coming in next year, and for next year I need to buy a motor, right? I just buy it. But in John Deere, as I say, I'm working from 2008. It's a global company, and many of the global companies across the world have a heavy investment in terms of their own development. I'm not calling production. Production, yes, as you say, is like Genus and those sort of big things who are very innovative and are ready to support. They'll come out to help you out in terms of production. But in terms of optimizing the solution, as we give the example, can we have SR motors at a small size, at a right cost effective, with the right controls, without magnet? Definitely, it's going to be way more cost effective, right? But you know, the SR is a very limited technology. Very few people globally also knows about how we control those switch reluctance motors sort of technologies. Axial flux is another technology coming in, right? Battery management is a new area coming in. The perspective is developing with a specific target in academia. Hey, you can take a motor which is currently in two-wheeler and says, I can develop the same motor with a reduced cost of 70%. I'll take out 30%, 40% of cost of it by just looking into the optimizing the architecture. Is it really required that much material for India market? You'll realize that most of the motors are even not designed for India. They are designed for a very different market, right? So industry is more about, as I told you the word, the young mind's analytical aspect. At a later stage, it's more about get the component and produce. But finally, there's an analytical aspect, how the machine operate. Is it for the right environment? Is it designed for India, or is it designed for minus 40 degrees US? I'm pretty much sure not in this case, but I'm pretty much sure China would have a different environment. We run into issues like machines designed for US, where they have minus 40 degrees C, and which is a very normal. In India, hardly 0 degree, we will say, right? If you design a machine and bring to India, it's going to be costly. So how we look into getting deeper into what exactly the machine design is. Can we look into the IPM motors? What is my right angles? What should be my flux gaps? How should I look at different innovative winding technologies so that my copper goes out? When you do it, I'm pretty much sure there will be enough investors to come out and says, okay, we'll develop the motor for you. But that design aspect of it, there are not many enough I'll say experienced people in the in the ecosystem who understand these nuances about what should be my fill factor in the motors, what should my air gaps, how should I look at my flux optimizations, right? How we are looking to my torque maximization and reducing the content of the magnet. So this sort of optimization problems, I'm pretty much sure academia should take a lead. And once you take the lead, I'm very much sure the big names you highlighted, they will be more than willing to work with you because they see how much money they are putting on this component on table.
Yes. Yes.
So we have to be more proactive and upfront provide this solution that, hey, we are optimizing it. What you are doing. Are you interested to collaborate with us? And I'm pretty much sure John Deere and many other organizations will definitely latch on an opportunity like this to collaborate. Thank you.
Sir.
Any other questions
So
from
other,
you?
yeah.
Yeah.
Any other participant? Please.
Yes, I have a question. As you mentioned about design constrainabilities, so I wanted to ask what are the challenges from industrial prospects as well as from the sustainability point of view required the prime focus?
Can you again come, Divya, more from sustainability? Are you talking about the global sustainability?
Yes, so the sustainable targets, because every country, not only India, but they are targeting 2030 targets also, all the designs and the policies that are coming forward, especially the phase policies that have come forward, are all keeping in mind their sustainable objectives.
So I'm saying you're talking about sustainability in terms of how we continue this effort, right?
Yes, sir. Yes,
Yeah,
sir.
yeah.
Yes.
Because sustainability also is about the environmental sustainability. I'll touch base on that fact also. See, there are aspects of this. Do we have enough raw material? Because finally it boils down to, let's say, what are the major components on an electrification? Motors and batteries, right? And as we discussed just now, motors have a very high dependencies on those precious metals, neodymium, which goes into the magnets, and those are very limited resources. And even if those sources are available, sometimes they are in conflict zone, in the war zone. We don't like to deal with those countries sometimes. So yes, there is a concern around that, but there's also solution being explored. Like there are different sources being explored around Europe, US. In India also there's an effort by ISRO how we can use indigenous material available to get this batteries being developed. Uh, Sustainability from materials perspective, I'm not very much concerned. It will manage. I'm more concerned about sustainability in terms of the demand. Currently there's a sustainability being created by government, which is by subsidizing the solutions. Government is subsidizing the solutions in terms of giving 30%, sometimes 40% coverage on like e-buses. China has done the same way to create the environment for there. China is the highest producer of electric vehicles just by providing the subsidies, and private public players are just latching on the electric vehicle. But the minute they start reducing the subsidy, we'll see a decline in the terms of the adaptability of electric vehicle. So we have to find a way that, because this subsidies cannot continue for infinite time. It needs to get to a logical stage where the market should pull in. That's where I am seeing the sustainability will go through certain sort of economic curves. It's bound to be, as we get more matured, it may go down and then again pick up. Good part from the government side, which I see to maintain the sustainability, is a focus on the commercial vehicles.
So,
See,
what you think about what economic model we should take forward to propose so that it's for the long run? Which model we should focus on?
so fuel side is on your I'll say arena with 110 rupees fuel and no side of coming down. The business cases are already started being created, very lucrative now. But again, think through what government is doing. See, commercial vehicles, right? I cannot push a public private owner that you don't buy a diesel car but you buy electric car. Everyone says it's a democratic country, right? I want to purchase what I want to purchase. But government can definitely tell its municipal corporations and everything in the world that, hey, all your public buses, all your the municipal buses should be electric. Government is paying for it anyway. Why don't they just make it electric? And that's what government says, it's easy to do it. And it's a viable economic model. It's not that government is getting losses. The numbers I see for Pune Municipal Corporation, they are making huge profit out of it because the saving they are getting out of it, lower maintenance, lower fuel cost, lower staff requirement, because it's basically on the complete operational model. The contracts are given like you just put the buses on road, manage it completely. So the operational cost is also low for the municipal. They're making a good profit out of it. Ola, I think you may be aware of this. Ola, Uber, they're getting into electric environment completely. Ola has a big factory coming in. Uber, big partnerships with players like Mahindra and others. They see a lot of commercial value. They are in the city environment, right? They see that the savings they're getting on this fuel, and even with the current rate they are offering and with some discount, they have profit margins will go significantly higher. So we have to find the first right business cases to pull the electrification. What happened with all this thing is then your volume of electric motors will go high. You cannot import that much volume from outside. You have to produce them inside. You have to produce batteries inside. There's no way you can import everything from outside for such a huge numbers. The minute that indigenization start happening because of this pull from this commercial segment, it become lucrative for private segments, because that the prices of batteries, prices of motor goes down, and then suddenly the fuel prices are not going to go down. Suddenly it's become very, very lucrative for me, and I can sense that okay, it's hardly costing me 20% more of a diesel, but in 1 year I'm getting more than 30% fuel savings, and it recover my money in 1 year. It's going to sustain itself. But yes, it's an interesting environment. What I'm seeing is that public sector or commercial sector will pull the electrification in India, and then once they able to sustain it, the profitability, then the private sector will come in, and then private sector in a way that private ownership of the cars will come in, and that then become the main adaptation of electrification will happen to us.
Thank you, sir.
Actually, one of our student startup at MNIT, they develop one e-cycle, and that's obviously we took that motor from China itself, and I'm using this e-cycle in our campus. So ultimately, I'm not bothering about 110, 110 rupees petrol and diesel price. But anyway, the one thing which I would like to add here, that our cycle can climb up to this Nahargarh fort.
Oh, great.
Yeah, that is, something.
That is another big area. And I really wish him to take it forward, because that's a big market coming in.
Yeah, but ultimately, some issue like angel funding and all, so many things are there which are not
It
because the
is.
startup need funding.
It is. It
But
is.
anyway, yeah, we are trying
Yeah.
something.
But what I'm saying is, there's a very lucrative market in Europe. It's a very lucrative market of
Yes.
e-bikes. Other things I seeing, especially in big cities like Pune and other things, there's a renting market.
Renting market.
And then we renting the cycle only. Like just outside my home, there are 10 cycles which I can just use my mobile and
No,
rent them
the
out.
same thing. But I would like to, I would like to do the same thing in our campus. But
Right.
ultimately, some issue from funding and all. The same thing with having a mobile app and renting the cycles for a student, staff like that. That's something that was in my mind.
Right.
I got it idea when I visited Baltimore in 2019,
Oh,
October 2019. I saw that cycle. Then okay, we can also develop it.
in Europe, it's a big thing. They just
Yeah.
pedal it. It's an interesting thing, but it has its own technological challenges, as I says.
Yeah.
If your battery dies down on a hill, you have to put double the effort.
Yes.
But again, we can talk offline around. You may have, but that's definitely a very interesting area, and that's where the young engineers should come forward.
Yeah.
Set up their
So I
own
hope.
startups.
I hope people who is there in the audience lobby must be listening this. So any other question from the audience side? Because after 5 minutes, our next session will start. So that is basically career in academia. So if you have any question, please ask.
I have one general question. Am I audible?
Yes, please.
Sir, what is your take on the statement like once you are into the academia, at least for 3 to 4 years, then your career in industry will be the end? there is no chance to getting into the industry once you are into academia for 3 to 4 years. Then what your perspective on this?
Not now in 2021. Yeah, in 21, 23, when Professor Akshay and myself, we were in the work bachelor's, master's, we think that way. That if you do PhD, then what happened? Are we in industry or are we in the academia? To tell you the fact, nowadays all senior jobs have a PhD requirement. To be very open, they want PhDs. If you want to get deeper into research in terms of batteries, motors in the industry, they expect that you should have your PhDs. Industry experts are very valuable because industries are now not just the working in isolation, and so the education. In my time, I never see a forum like this. You are in academia, Dr. Arun providing this platform where we are interacting. He's looking at industry problems, and that's where the academia will also do. Look into industrial solutions, and definitely there may be some handshake where if there's an interest in academia side, to come back and says, okay, I want to now get into development, because academia do the development. That's why I'm telling in terms of upfront research. I can optimize, I can analytical show you a new machine form, which is a better option. It's not academia job to take it to the production, get into the market, find out the marketing things. But yes, if there's an interest that, hey, I want to get into this all developmental cycle, I'm very sure industry will be very with open arms, will take out the right people from academia. And it happens. Some of the best people in my John Deere career I know are professors who are being hired by John Deere from the universities. It happened both way, by the way. Industries also now want to go back to become academia. tell you the Tell you the fact. So
So
it's
what is your suggestion?
exchange is happening both way.
So what is your suggestion for those who wanted to enter into the R&D after their doctors? Uh, how can they mold himself or herself during the starting of the doctor PhD?
See, if you're looking to enter into industry just after your education, like master's or PhD, definitely look into what is the relevant challenges. We know what are our challenges we are facing, like battery technology. The current technologies of battery is not going to sustain. There's already new technologies, fuel cells coming in. In machines, we already talk about new technologies like SR. If I need to get into electrification and I get a very good candidate in doing masters and PhD in this area, I will just latch on it. Forget about requirements. We don't find right people in the academia in terms of MTechs, BTechs, who has this right skill sets. But if you're getting those right skill sets, understand the simulation tools, MathWorks, and some of those things which are directly being required for your job. Now, if you're sorry, okay. Just ending on my thought is, if you are in like 5-10 years in academia, that you start your career as a lecturer, professor, and then you want to get into industry, I'm very much sure all the professor I know already have some connect with industry. Most of the professors, and especially like Dr. Arun, uh, Dr. Professor Akshay, they are very well recognized and recognized across industries and corporation. So ensure that whatever you are doing in academia, even if after education you want to start in academia, have your industry connects. Work with industries to find out what are the problem statement you want to solve for them, and that will keep you connected to industry. So if there's any thought in terms of, hey, I want to shift towards a more industrial domain, that will be a smoother transition.
Thank you.
Thank you very much.
Thank you, sir.
Thanks.
Divya, you can conclude now for Bhupesh sir.
Yes,
And
sir.
after that, we will start another session.
Yes, sir.
Thank you, sir. Thank you from my side. Divya, please continue.
Thank you, sir, for this insightful session pointing towards the various aspects of the industrial operations and the changing dynamics of Indian ecosystem. Thank you again, sir. Our heartiest gratitude for the multidimensional discussion. Thank you, sir.
Thank you, sir. No.
Thank you, Divya. Thank you, Arun. We wish you all a very good evening again. Thank you very much.
So, Divya, we have a next session right now. Our both the guests are here in the list. Professor Biplab Sikdar is there, Professor Anurag Srivastava is also there. I think both are present. We can see from, yeah, both are there. So I welcome you, sir, Professor Biplab Sikdar and Professor Anurag, sir.
Yeah.
Yes.
Yeah.
Hello,
Thank
sir.
you very
How are
much,
you?
Dr. Kumar. Yeah. Thank you.
I hope everything is fine, sir.
Yeah, it's good. It's good. Yeah.
So it's around 8:30 in Singapore.
That's right. That's right. It's 8:30 here.
I had been there in NTU Singapore for
Yeah,
my
I
postdoc.
saw you were an NTU postdoc,
Yeah.
and I think it's not so bad for me, but I think for Anurag, well, it's 8:30 in the morning. He's on the East Coast now. Otherwise, it would be
Yeah.
5:30 for him.
Yes, yeah. Hello, everyone.
Welcome, Anurag, sir. How are you? It's a nice thing behind you.
Yeah, thank you. Well, this is our
It's really
university
refreshing.
campus.
Okay, great.
Behind me.
This is great. So, sir, we can start the session. That is basically, I mean, we have around 100, and more than 100 participants. That is basically the session is all about career in academia. So, Divya, could you please introduce our speakers and then we can start?
Yes, sir.
Divya, please.
Yes, sir. For the career dynamics in the field of academics, we have Dr. Biplab Sikdar and Dr. Anurag Srivastava. Dr. Biplab Sikdar, sir, Associate Professor, Vice Dean, Graduate Programs, and Area Director, Communication and Network, NUS, Singapore. He received his MTech degree in Electrical Engineering from IIT Kanpur and PhD in Electrical Engineering from Rensselaer Polytechnic Institute, Troy, New York, USA. His research interests include transport protocols, network security, and queuing theory. We also have Dr. Anurag Srivastava, sir, Chairperson, Department of Computer Science and Electrical Engineering, West Virginia University, USA. He received his master's from IIT BHU and PhD from Illinois Institute of Technology, Chicago. His research interests include data-driven algorithms for power system operations and control, including resiliency analysis. Now I request Dr. Biplab Sikdar, sir, and Dr. Anurag Srivastava, sir, to begin the enriching session. So,
Okay. Thanks. Maybe I have a short presentation. Maybe
Sure, sir.
I'll go with that. All right, so maybe I'll talk a little bit and then we'll go to Anurag and then maybe we can answer whatever questions students may have. So I just want to give you a brief overview of, for those students who are thinking whether they want to be in academia, they want to be in industry, I just want to give you a highlight of what it means to be in academia. And I mean, I don't know anything about what it means to be in industry because I never worked any honest days work in my life. So I've always been in academia. So I'll just give you the academic viewpoint of what things are, right? So most of you are probably students in the audience and you're maybe doing your master's, maybe you're doing your PhD, and your graduate school, what you're right now, teaches you to do research, right? So that's what you do. You learn how to do research. You learn how to solve research problems. You learn how to publish papers. But then when you become a professor, maybe that's not the only thing that you do. Now you are responsible for many more things. Your job duties are much more diverse. And of course, you will, as a faculty member, as a professor, you would be doing research. But on top of that, a lot of our time goes into finding funding, managing money, managing, accounts and so on. So you would be playing the part of a finance manager to some extent. Of course, you'll be teaching classes. So you'll be a teacher out there. You will be dealing with students, and dealing with students, dealing with staff comes with their own set of issues. So maybe you'll be solving problems for people. You would be a mentor for people. You'd be sort of acting as a therapist for them. And part of your professor's job is also to attract funding, selling your ideas to both paper reviewers as well as to funding agencies. So you also serve the job of a salesman or a saleswoman to some extent. Right? So it's not just doing research. It's not just publishing papers. Right? So one of the things that you have to answer at this point in your life is to say whether you want to be in academia or you want to be in industry. Right? So the previous speaker, he presented what it means to be in the industry and what other things. Right? So if you are trying to think whether you want to go to industry, you want to be in academia,
Hello.
there are a few
Sama.
things you want to think about, right? So what are the so one thing that so you want to think about how the academic job differs from an industrial job, right? So here are some things that that are there. So one is your responsibilities. So some of the responsibilities I already talked about here, which are in academia, right? But if you're in industry, probably the job is a little bit more towards, you know, you're working for a company. A company usually has financial interests. Most academic jobs, at least, you know, they're non-profit, so they're not out there to make money. But if you're working for the industry, you would be driven by deadlines. You would be driven by profit margins and things like that. The other thing might be in terms of flexibility of your timings and jobs. If you're in academia, of course, you have a little bit more flexibility, right? You don't have to show up from 9 to 5. You are in bit more control of your own calendar, your own schedule. But if you're in industry, maybe you have to follow a bit more regimented timeline, which some people prefer, some don't. So it's up to you, right? Even if you look at the collaboration aspects, academic jobs can be very collaborative, especially, you know, you would work closely with your PhD and master students. But that's a different kind of collaboration. And if you're in the industry, you would be working in a team, and the collaboration will also be there. But then, you know, the difference really is that if you're a professor, you are sort of leading your own group. You're leading your own research. Nobody's up there for you, telling you what to do and so on. So whatever collaboration is there between you and your students, but in the industry, at least, especially when you start off, maybe it's a bit more of a group thing. Okay? And that's also part of what the workplace culture may be. Usually in the academia, it's a little bit more offhands. So you're your own boss. But in the industry, maybe things may be a little bit different from that. And the same thing goes on when you talk about impact. So here, as a professor, whatever you do, it belongs to you, right? You are the one who led that research, or your students did that. But in the industry, maybe you're a little bit more on the sharing mode. You work as a group and achieve things as a group. And if you're a professor, you have a little bit more intellectual freedom. You can pursue the problems you think are important rather than, you know, being driven by what the market needs and short-term profit and so on. Another consideration that you may have is about salary. In general, academic salaries are lower than industry salaries. You would end up making more money, right? So, you know, my PhD, when I was a PhD student, my roommate, well, one of them, he now works for Intel. So I'm sure he earns more than 3 times that I do, or at least twice. But then, you know, we have a little bit more freedom. So or at least I console myself by saying, you know, I have my own freedom. I decide what to do, and so it's okay even if I earn less. So that's something you may want to think about. And then the other thing is about career advancement. So if you're a professor, you know, you'll go from assistant, associate, full professor, and then, you know, if you're inclined towards more administrative things, you can become I don't know, deputy head, dean, vice dean, whatever, those things. But then if you're in the industry, the career advancement may be very different. And for some people, being the CEO or CTO, leading a large organization, taking care of a whole company. So there are different pathways. And again, it depends on what you sort of prefer. So what is right for you, or whether academia is right for you, it's something for you to evaluate. So I'll just list the pros and the cons of an academic versus an industry job. So the good things about academia are that, you know, you have a lot of freedom, and the time is up to you, and you can set your own research direction. I personally love working with my students. And I actually learn a lot from my own students. And the teaching part of things, some professors, they love it, some may not care so much about it, right? And the bad thing is, the hours can be pretty long. So on an average, especially at the beginning of people's careers, if you're working 8 hours a day, 5 days a week, that's about 40 hours a week. In academia, it's quite common for people to be working like 55, 60 hours a week, at least in the beginning, right? And another thing is, when you're a professor, especially this is, I think, increasingly common in India also, you have to find funding for your research. And that can lead to a lot of pressure, right? It's not always very straightforward to secure funding. This tenure process is about, I'm not sure, I don't think it's very relevant in the Indian context, but in the West, when you start off as an assistant professor, you get 6 years to prove yourself in some sense. And if you prove yourself, then you're promoted to an associate professor, and then you have your job for life. It's very difficult to fire you. I think in India may not be the same thing, but I think at least in the beginning, it still might be a little bit more intense or pressure building. And of course, some people think that I will become a professor, I'll do my research, I'll write papers, but then they also they don't think about teaching so much, and then teaching creeps up on them. So that's something. So if you're still on the fence and you're trying to think which way do I want to go, many ways you could see. I think the best thing is you decide your priorities. What is the one that matters more to you? For example, do you want a high salary, low salary? Do you want intellectual freedom? Do you want flexibility in your work hours? That may move you one way or the other. You also want to think, as you grow older, how do you really want to spend your day, your work hours? How much do you care about teaching, publishing, and fundraising, reviewing papers, and so on? You may also want to think in terms of what kind of a person you are. What are your strengths, right? If you're a professor, you're sort of on your own. You manage your own time. You manage your own research. So it's good if you are a self-starter. You're very good at time management. But on the other hand, if you prefer a much more structured regimen, much more structured environment, where you go in the morning, you have fixed goals and fixed timelines associated with it, maybe the industry is a better place for you. And then you should also think about your personality, whether you prefer to work independently, you prefer to work with others. If you're in academia, a lot of it, you have to promote yourself. You're on your own. But if you prefer to be working in a team, sharing your successes with others, industry is a good option. And then again, you think about where you want to be in 5-10 years. And I think the last question to the previous speaker was, if I'm in industry, can I move to academia? I do think increasingly you can, and if you want to go industry or academia right now, of course, that's not your final decision. You can always change. Though I do think that it's easier to go from academia to industry after 5 years than to move from industry to academia after 5 years. That's just my opinion. And ultimately, you just be true to yourself. You think where you want to be and then decide accordingly. Don't go by what your peers are doing or what your parents want you to do, and so on. So now coming quickly, I think I'm almost getting to the end of my talk. So if you want to be in academia, what do you need to do, right? So let's say you still decide, I want to be a professor. So there are certain things you do as a PhD student. And the biggest thing you can do is to publish, right? So publish as many papers as you can. Of course, it's not a question of volume. It's also a question of quality of your publications, right? And most of you probably are from engineering. So I did say that, journals tend to have a lot of value for us, those who are in engineering. But then you should also think about conferences, and especially because of the contacts that you can make when you go to conferences. So when you go to a conference, talk to people, try to introduce yourself, make more contacts, and so on. Another thing that I encourage my students to do is, take more courses. It's not just that the courses don't have to be exactly in your area. When I was a MTech student in Kanpur, I used to tell my advisor there, sir, so I was a networking person back then, computer networks. And then, sir, in Hindi, no, I don't know, actually, I don't think, no, it cannot be Hindi. He's a Kannada speaker, right? So I said, sir, there are no courses in computer networking here. Or I did 2 or 3 and there are no more. So you'd say, go and take as many different courses that you can in other areas. Because ultimately you will not stay in the same area throughout your life. The more courses, the more breadth you have, the more information or knowledge you have in terms of skills and tools that you can get to solve problems. Right? So do that. If you can get any fellowships, that's a good thing, right? It adds prestige, it builds your CV. So try to do that. And anytime you're writing papers, so this is sort of related to my publications thing, polish your talks, polish your writing. It's always good to have good quality papers out there rather than focusing just on the volume, right? And increasingly, as I'll say later, and there are a lot of, for every position that we put up, you will get more than 100 applications. So your CV, your resume needs to stand up. And one of the ways you can do that is to do things that a professor or faculty is expected to. So for example, if you can highlight any teaching that you can, could be maybe just grading at the very least, but if you can highlight those things, that's very good. Many universities worry about whether you can get money, right? Research funding. So if you have any grant writing experience that you can help your supervisor to do those things, that's very good. And after you finish your PhD, one good thing is, previously for engineering students, we didn't really need to do a postdoc, but it's increasingly becoming common. So you go and do it. Maybe you will have to do a postdoc. And while you're doing a postdoc, there's a sweet spot for it. You don't want to do it for 6 months. You don't want to do it for 5 or 6 years either. So I think 2 to 3 years is probably the right spot for you. And while you are doing a postdoc, one good thing is don't do the postdoc in the same university you're in, ideally, right? If you cannot help it, you can. For example, if you're on the verge of a breakthrough, you can continue with your university. And even if you're continuing in a university, definitely choose a different supervisor, right? There may be exceptions, but different university, and definitely, if you're in the same university, choose a different advisor. Try to stay visible, go to as many conferences and so on. And while you're choosing a supervisor, look at their track records. Where have their postdocs and where have their students ended up? Once you've finished your thing, your postdoc, the biggest challenge now towards your academic career would be to get the interview. And the main challenge here is that there are many applicants applying for the same job. So what you do is have a very strong CV. And a very strong CV again is your publication list, the places that you're publishing, and also the quality of those publications. And another thing is that it doesn't hurt to have an advocate, right? So if you're applying to University X, if somebody in University X already knows you, that's probably the best situation for you. So how? Usually the way is to go through conferences, right? If you go to conferences, talk to people, they have seen your paper, most likely they will remember you and then speak up for you. And then during the the interview itself, I think it's same in India also. A big thing is the job talk, where you're supposed to give a 45 to 1 hour talk on what kind of research you're doing. And here again, the level is, you should keep a motivation which everybody understands. And then you should also have a technical content which is really at quite a good depth. And don't be very modest. Talk about your contribution, speak up, make sure people know the quality of work that you have done and so on. And another big thing there is you talk about your future work, 2 to 3, 4 topics, and they don't have to be a continuation of your PhD. Capable of expanding your horizons and then go on. And then in the West and in the Singapore, we usually have individual meetings with many other faculty members. So here, what you want to do is you want to show that you're very enthusiastic and you're willing to collaborate and so on. And after you get the job, to me, what is the biggest thing as a PhD student, as a faculty, is that, you want to learn how to select a good research problem to work on, right? You want to select a problem that's going to have a lot of impact that people care about. Increasingly, multidisciplinary research areas are becoming more and more important. And then again, if you are working in a university where the resources are limited, you should choose your problems accordingly, right? So match the strengths and weaknesses of your environment. And if you're picking a problem, picking an area, make sure that it's exciting and promising enough so that you can work for at least 3 to 5 years in that. Try to get feedback on the work that you're doing. Don't worry about negative feedback. If you get negative feedback, take it, as a constructive feedback. Be very, very careful about when you pick your members of your students and your team members. And then, another big thing about working is that you have to learn how to sell your work. That's the salesman person that I was talking about earlier. And then don't be afraid to change the field during your career. Just because you are in computer networks doesn't mean you'll stay there forever. Personally, I started as a networking person, and now I do more of cybersecurity. So that's normal. Okay. So that's sort of what I want to, very quickly. Maybe I spoke a little bit more than I was supposed to. So I'm going to stop here, and maybe later on after Anurag finishes, then we'll go to the questions probably. Thank you.
Okay, so if you're going to take question in the end, I can.
Yeah.
We also have a slide and share it. Are you able to see it?
Yes, sir, we are able to see it.
Okay, well, so I have a very similar message with what Biplab was just talking about. So first is that why career in academia, and Biplab already talked about something, but for me, it's watching my students grow and blossom in the reward of our efforts, right? So that's a big impact. I do understand that we have a big responsibility to transform the next generation. So if you come into academia, you have a direct impact with the next generation and in a large number, right? The other thing is that if I like my profession, that I want to impact it of course, in a positive direction. And there are multiple opportunities in academia through service, in fact, most of the faculty here in the US are supposed to do a service and interact with outside. Freedom to do research in interest area. So, and you can change, like Biplab said, over the years, right? And also, another thing is that your performance is, of course, is being seen by who is your upper supervisor, like a dean or department chair. But at the same time, a lot of our publication and if you write a project is going for a peer review, right? So your collaborators or your network is going to probably see that. So that's very different than industry. This is a quote from another person: that the teaching is a form of magic. It is an alchemy in which we try to help young people find the goal within themselves, right? So you are basically helping them. But finally, all is your choice. What makes you happy and what is your personality, right? Flexibility versus structured work, industry contributions, higher impact versus, one thing is sure that here also we do have a lower salary compared to industry, and I guess that's a trend almost in most of the country, right? So continuing on, it's what's like to be in academia. It's very different than what was from school to college to university. And you typically go to academia because, again, you like a certain role, the role that we just talked about, impacting life, impacting, being happy while teaching your students and doing some research and making impact. But very few who do PhD become a PhD, after become a faculty member. And if I look at the data, it is a little bit old, but still it's lower. And every field is different. In engineering, there are only 6 to 5% or 7% who become faculty after doing PhD. So, and there are reasons for that. There are so many R&D jobs. There are so many different opportunities that PhD students have compared to other fields, like in education or social science and life sciences. Other thing is that, of course, it's challenging and tough to get a faculty job, right? And life is very different. So if you look at when you're a student, you worry about different things. For in this example, this cartoon is saying that paper is a few pages too short. How do I make it longer, right? When you become a professor, you're saying that it's too long. How do I make it shorter and concise? So it is very different the way you used to think as a grad student and postdoc, and the goal changes once we adapt to the professor job. Professor are different kind. So this is from the students, how they think that what are the different professor you can become. Some will say that don't worry about the grades and understanding is what important, but which is called idealist, the old school European, which is several different focus on more research and typically is very high up compared to students, and then say that you should know what it means. So every different kind, and of course this is not a complete list, but this is I found it funny that how students think, right? That what different kind of professor exist. We talked about that, and India is very similar. Some school has UK that you become lecturer, then senior lecturer, reader, professor UK, and then in USA we have this assistant professor, associate professor, and full professor, which is again very common for like IITs, right? So and MNIT too. So we follow both kind of model in India, but after full professor, you might go in administration, might become a research center director, or you might become a chair professor. There are some universities called super professor, that there are some rates for that. So different hierarchy for academic profession. My journey in academia has been, very diverse, I would say. So after IIT BHU, I was in IIT Kanpur, India, and then I went to Thailand as a research fellow. Then I came back to Chicago to do my PhD, and then I joined as a first job, which is an assistant research professor at Mississippi State, 2005. And then in 2010, I joined Washington State University, and I became associate professor, and I took a 1-year sabbatical. So that's very common here, that you take a sabbatical for 6 months or a year. And I spent my time interacting with different institutions. So I went to industry, which is a PJM, which is a grid operator. I went to MIT to learn more theoretical stuff. I went to Idaho National Lab to learn about cybersecurity and work with them and the power grid. I went to GE to learn about what's the vendor perspective, to make a software to operate the grid. And then I took a lot of service job, like being, for example, as like associate editor for transactions. I also organized, become a chair of different conferences, which is very important as we try to do. And then I continued my sabbatical for 1 year, which becomes like a 15-month, and went to Germany to spend some time to see that, how European university operates. Went to France to see that how French grid operator operate, and everywhere I spent 2 to 6 months or 7 months, depending upon who is paying me. So that is important too. And then I spent some time as a manufacturer. SEL is they make industry. One of the industry in the power grid who makes production devices and who makes a lot of hardware devices to protect our grid. And then I spent a lot of time at PNL, and I liked it so much that every summer I thought that I should go somewhere. So I spent another 3 months in one of the reliability coordinator in west of USA, which is basically WEC. And then basically on the way we chaired a lot of conferences and a big project. And then PNL work during my sabbatical, I did like, and it was not too far from my, at that time, institution, Washington State. So I joined there as a senior scientist, as a joint appointment. That helped a lot because you understand that what national research is going, and especially in the energy area. And then in 2021, I became a full professor at Washington State, and then I transitioned to West Virginia as which did not come very right, as an endowed professor and a department chair. Again, I am also, for example, technical chair for Smart Grid Com. So I continued my service to different conference and journal as much as possible. Now, in the whole process, what I try to practice is, be organized and prepared and engaging as much as possible. Have a positive attitude because I'm doing this job because it makes me happy, right? And otherwise I'll not do that. And it should be that I should be very approachable to students and everyone who wants to do, right, as much as possible again. I understand that we are trying to become a role model for our students. So as much be inspiring to them, that's good. Like Biplab said, that you should be open to change your topic if needed, if because the field is evolving. So being a lifelong learner. And then the other thing that I think is very important for the impact on the world is that we encourage students to become entrepreneur. And when we talk about what we teach in the class, we also tell them that there's a big gap in industry on this topic, and let them find the right resources to explore that. Of course, top quality publication is very important as a faculty, and we, that's a big impact for us when we write those and how many people read it, which is citation typically. Should be active in organization. And also get mentored often. So we should have a set of people who we closely work with for different questions and learn and from their experience and again do service. So to summarize it, there are a lot of possibilities during and what did I learn is that every year, I have a lot of possibility that what I want to do, but few things which is important as a faculty member is I have to be thinking about, what excites me. What's the research program that I would like to establish? What's the academic program that I would like to establish? And follow that, right? And I do that by building a network of, again, several people and keep learning, keep a tie with industry, keep a tie with our peer in academia. And as I learn new things, I integrate that into what I already learned in my teaching, right? So that's very important. And then having a positive learning experience for the students is that's our primary goal as a teacher, right? Recruit and train graduate students. Again, this is going to impact their master's and PhD student we're talking about, and that's what they do their dissertation or research on. So I have to spend a lot of time and energy on that too. And that will result into a top quality publication with some impact. And it's very important that whatever we do, we share with the world, right? Either it's a paper, or it's a conference paper with some just a presentation, or some patent that we turn out to be maybe a startup finally, and that will loop in. So we are on path on a spiral. You start with somewhere, and then you start with some research and academic program, and once we go through these steps, it will feed in again to build a more stronger program and with a higher impact. Another thing is that, which is very important, and it was said by several different people, is about work-life balance. So this is a story about juggling 5 balls, which we are all doing, right? So imagine your life is a game of 5 balls that you can manipulate in the air, trying to not to fall these balls. And one of them is rubber ball and the rest is glass. And in fact, these 5 balls are your work, family, health, and friends, and so on. So you are talking about work right now, but understand that work is the rubber ball, which will bounce back if you leave it. It's okay. But the other one will not. So your family, health, friends, and soul will not. So take time to stop and take a break and spend other 4 more important, because you have to keep juggling all the time. To learn from this is if we do what we like, then we can easily switch between, because I'm sure that we all like family, health, and friends, and so, and work will be integrated there very well. At the same time, knowing that where to focus on, right? So this was the statement long back in a different way, was said by Brian Dyson, who was the CEO president. And Sundar Pichai just said, I think last week or last month, in one of the talk about this, especially with all the extra work that we get during the COVID. With that, I'll stop and thank you again. And, thank to our organizers, and maybe you should be ready for questions.
Thank you, sir. Thank you very much. Now, I think I can ask the people who are attending the session, please ask your questions.
Sir, I'm Dr. Sharmila from Anna University, India. Sometimes the faculty members in state universities don't get the right time the promotions. So it gives a lot of pressure on us, like that is left in your talk. So even though we do some quality work, we being a state university, we will be interviewed by our NITs and IIT professors. So there is a hierarchy, as you rightly said, assistant professor, associate professor. So the right time, we never get certain time. So how the faculty member has to cope up? So some kind of a self-confidence, along with the self-confidence, some kind of energy level is to be there, that we get self-motivated also. So which I wanted to add up on, professor. And the second question would be like the postdocs. So certain faculty members like me, I have crossed, I've joined Anna University when I was just 24 or 25 or something like that. So now this is my 20th year of service I completed. I am 40 years old. So postdoc I have not done in my initial career. Like I completed PhD in 2010. So this 10 years gap, can I take it up again postdoc, and is it advisable, professor? I could see both of you have really told the teaching in a very beautiful way. Sarvapalli Radhakrishnan sir is alive, means he would definitely enjoy the way you spoke, sir, professors. So thank you for a very wonderful insight about the teaching profession. Thank you for the opportunity.
Sure, yeah. So let me answer the second question first, because that's more easier. So I think there's no timeline for postdoc, and anyone where they want to become ready for that, they can take a break from your academic life and take a postdoc. And also there are several opportunity in India for the fellowship and like a Fulbright fellowship, and there's several others. And a lot of faculty have done that, even with me in the past. And so that several other faculty in US, in Europe and Australia. So there's no time or age limit on that. So anyone can do that anytime when they think about it. The first one is something that is not the problem of only teaching, right? It can happen anywhere. It can happen in industry. It can happen in in any different kind of job. And there's no right answer to that what to do, which will help to get promotion. So as long as you have an external reputation, as long as you have internal reputation, you have less reason to worry about, and you have less things to be evaluated by the whoever is evaluating your promotion to think about, right? So external, internal, both things is put in your resume will put more pressure on whoever is making decision. I think I'll just leave it on that note.
Actually, one thing I have, okay, if your question is over, yeah. One thing which I have noticed in the Indian system, basically, I'm not criticizing anything, but sometimes they put a age bar, okay, that for an assistant professor in IITs or some, there's nobody written, but there's a hidden rule, or somewhere some IITs or NIT, they wrote like 35 is a desirable age, or maybe something like that, okay. So that is something I found very, I mean, it's not good, because because I was in UCLA, I was attending to Singapore, I have attended the faculty seminars also in both the universities, and I never find this criteria that 35 you are not eligible for assistant professor, something like that. So I mean, how to tackle that, and what could be the suggestion from your side? Professor Biplab is there, Professor Anurag is there. So question is to both.
And similarly, Dr. Arun, we also have a restriction to take sabbatical leave. They give 5% or 2% thinking about.
That is another issue, but I mean, top institute
Yes.
like IITs, if they are playing with age, then definitely the things are, once you go through this MPA, BTech, MTech, PhD, 30s, I mean, something that you have to cross, okay. And if you're, I mean, that assistant
you're right.
professor, they kept us some 35 something, so that is something problematic, I found it. What is your view on that?
No, I agree that there
Yes.
should not be any age-based discrimination on, you know. One of the most prominent people that I know in the networking, she became a professor much later in life, like maybe after 50 or something, and then that's fine. I think that's very unfortunate that if somebody puts an age limit on when you can start, how to, you know, stop that from happening, that's a much more difficult problem. Yeah, I
No.
think maybe legally or legislatively.
No, but I mean, this is my personal experience, and I suffered through this because I crossed 35, 36. I have a grant of around 5-6 crore rupees in Indian rupees, PI of 4-5 projects, 2 patent I have applied. I have around 18 publication in IEEE IT, and some of the IT is not shortlisting me because I'm more than 36, and the student, they are the people they are shortlisting, they are little funny. I mean, not little funny, more than funny. No research project. Okay, they have a publication, but no research project, nothing like that. But still, they shortlisted, and somehow they managed to get into the system also. So that is something. I mean,
yeah, that's not fair. I don't think it should be like that.
Yeah, so I agree that it's not fair. And I remember having a discussion on this with a couple of IIT faculty, and you know, they're basically following what's the rule, which is from Department of Education and, you know, ministers, and I think the solution is very challenging and difficult, like Biplab said, but it does not mean that we should not make effort. So if that need to change, the justification is that we should give enough time for them to become a full professor, and that's why we want early. But, you know, things had changed. I mean, the new pay certainly was, you know, applied after a group of professors put the plan together and took it forward. So for this thing, same thing. If you, you know, group of faculty who form a group and then you know, involve key people who interact with a government, and then take this forward, you know, things will change.
but I mean, you probably you might be interacting with some of the directors of so-called IITs. So
yeah.
I mean, that sort of thing should come out. And I mean, see, old IITs generally they are not doing it. Okay, but new IITs, they are doing it like pretty well. I mean, if you are more than 35, they won't shortlist you. Something like that.
And in the promotions also, sir, when they are 40, they are telling very young age, you have to become 50 to become a professor. Some mindset is there. So we cannot make our hair gray and tell them that we are older now to give promotions. Maybe they can, the professors can talk to some prime minister's office if they are able to be a board advisor or so to do some improvements for India, because like bilateral relationships.
That is okay. That is okay. So
Yes, just on the lighter side, I wanted to. Thank you.
any other, members who is attending this session, any other participant, if they would like to ask any question from the audience side, please.
Sir, I have a question to Biplab, sir. Sir, you mentioned very correctly that we should be learning as much as we can, and I also believe in that. But sometimes, when we are actually making our CV for any universities or any positions, then there comes a criteria that we need to make it in that sort of way, like we need to centralize it in some certain directions. So what is your point of view on that? Like what can be the, how can we prioritize what we actually need to mention on that or what we shouldn't?
So you are absolutely right that, when you apply, and if I am in the search committee and I'm looking through, let's say, CVs, I want to see that you have a body of work in a particular area. So I can tell that, okay, this person is an expert in this, right? So that's from the CV building point of view, right? So you pick an area and you build up a body of work in that. So I know that you're an expert in that. Now, when I talked about the coursework and learning other tools and other techniques, that's not part of your CV building exercise. That's more of building you up as a researcher who will be successful maybe in the future, because, so for example, if I just know how to do, let's say, if I had done a course in, let's say, probably many of your electrical, power systems or power engineers, so I'm just trying to find the right word to say, if I had done just a course, if I just focused on computer networks when I was a PhD student, which is sort of what I did, I could be only capable of solving problems in that area. That's fine. But then in order to solve problems in computer networks or power systems or whatever, if you know how to do optimization, that might be useful. If you know how to do things like these days, machine learning or AI, that might be useful. So that's what I'm trying to say, that, the tools or the solution techniques that you learn don't necessarily come just from your domain. So to build up your capability or to learn different things, you take courses to broaden your knowledge. But then at least when you're looking for a job, or even when you're an assistant professor looking for tenure or looking for promotion, I think it's better to focus on a particular area. But then to solve those problems in that area, you may draw on techniques or knowledge from other related other specializations. So that's sort of the point I was trying to make there.
Okay, sir. Got it, sir. Thank you.
Yeah.
So any other question from the audience, please? So if there is no further question, because we left with 10 minutes. So, sir, any advice, any special advice from your side to our audience? Maybe
Let me add some more points for the last
please.
question. So I'll give you an example that, we were teaching a course where, which is basically about cybersecurity of a critical power grid infrastructure. And that is even beyond my expertise, right? So we had a 4 different faculty teaching that course. And one of the professors said that if you look around the class, half are bored and other half are terrified. And the reason is that, when I'm teaching, then all the power engineering, students will be very happy and know that what I'm talking about, and maybe already know, so they'll be bored. But when the cybersecurity person is teaching, or networking is teaching, or computing is teaching, then they will be not. But our objective was to teach them collectively and still call them, if they are a power expert, they still be a power expert. They're not going to be expert in other area by taking that course, right? So if they are power electrical engineer, they will be still putting their CV that they are electrical engineer as a power. But they know about that, what is the networking applications in power grid. They will know about that, what are the cybersecurity problem in that. And once they do it, then they do have a much better perspective to either for industry or for academia, because they understand the bigger system level problem. So understanding the peripheral thing while still focusing on one topic is very important, because you have a better understanding compared to your colleague at any given time. Other thing is that according to neuroscience, our brain becomes function better if you keep learning new things every month, which could be anything, which could be music, which could be new art, or which could be any other thing that you develop interest into. And then you continue that, because you're firing a new set of neurons in your brain, which will help in understanding other things in a larger sense.
So one more question we have from one of our audience, that's, sir, how to make a balance between teacher and learners to fulfill course outcome in online mode?
A very good question. And again, there are not a single thing that we can outline that which is going to help with that. So you have to do a series of things. As a faculty member, teacher is your first responsibility, right? So you are basically, if you're teaching that course, then we have to make sure that we are updating the course material by learning new things and still keeping the fundamentals in the course. So that is very important. And when we get time, which might be once in a few months, or once in a month, or sometime once in a week, then you become in learner mode and then try to learn new skills in that. But for related to that topic, you are always in learner mode, right? So if you're teaching a course, you're always interacting with students, which means that you are in learner mode most of the time. But if you want to learn a new thing, then it's whatever time you can get. Now in online mode, it's much more challenging, because you have to spend more time in teaching something which you will do in the class. Students will get more what you will do in the class compared to what you will do in online, right? Because they will be more engaged. So engagement is very much important, and online engagement is typically less. Now, how it can be done in a better way, there is, again, there's not a single solution, but typically it includes, trying out things that they will like. And there are multiple different websites which, ask you to take a break in 5 to 10 minutes when you're done with your single topic, and then ask questions immediately. There are some website which I use in my class, which is for brainstorming, which means that I ask question and they put, without responding to me, they have to put their answer in that website, and it will be tracked. You can put a grade that if you respond there, you will get 1 point for that assignment, or so there are multiple ways to increase the engagement, running the video on, providing a link where they can provide more and more information when you ask question, and putting a grade for that. And then there are some online games which you can play to keep it in line with, again, keeping their interest. but there is no best solution that exists for online mode, unfortunately.
So one more question from Professor Biplab. The participant is writing, my question is directed to Professor Biplab. I would like to ask you about how to make a smooth transition into a different research field for PhD studies from one's master studies.
Okay, so I think, when you apply, so I think in the Indian system, it may be a little bit different, but when you apply to Western universities or Singapore, usually the way it'll work is you apply, and then the professors in the department will go through the applications, or you can also send them an email directly saying I'm applying and so on. And they will go through your profile, and then they will verify that, you meet their requirements in terms of their expectations for academic grades. And increasingly, what we also look for is whether you have any relevant research or work experience in that area. So if you are trying to transition from area A to area B, it would be good to provide some kind of an evidence that you are comfortable or you're capable of that area, of working in that area. And either it could be, these days it's quite common for students to do, like edX or other online courses in that area, or sometimes you can also, I get emails from students who may not be in the same area that I am, but they read up papers in that area and then they give a nice little research proposal in there, or they give a nice critique saying, these are existing problems, and I think these can be addressed in there. So I think the onus is on you. You have to do a little bit of groundwork. You have to do some homework to show that this new area that you're going to work in, you have some amount of familiarity with it and you're capable of working in there. So either you do that in terms of showing some online courses you have done, or reading up papers, or maybe even publishing in there. That's probably the way to go there.
So any other question from the audience side, please? So I think, yeah, one more question.
Yes, sir. So, students who are going for masters, if they are not, applying for a master's course just after completing their bachelor's, so is it necessary to have certain experience when we are actually like going for MS? So do we need, if we have a strong profile, like we have done certain projects and things like that, then is it necessary that even if we are taking some drop because of certain situations, so is it necessary that we should have some kind of work experience like that? Sir, for masters, like MS or MTech.
I'm just trying to understand your situation. So you finished, let's say, not you, let's say the student finished the undergraduate program, and then they took some break for whatever reason, whatever they were doing, and now they want to apply for masters.
Yes.
Do they have to show that they were doing something during that time?
Yeah, like did they do something in the particular field that they are actually?
No, not necessary, not necessary.
Okay.
Yeah.
Okay. Got it.
Anurag, you have a view on this?
Yeah, I think someone who has done masters and also has some experience, either internship experience or some work experience, they might get more higher ranking in terms of when we look at their CV. Again, if someone has not that experience but has published 2 papers already in masters in that specific area, sometimes it's useful, sometimes it's not, depending upon the project that we are going to hire a PhD student. And industry experience makes you more professional, and our internship and more mature. So that might be taken as a positive. Depends upon a faculty.
one more question is how to motivate students about pragmatic societal benefiting projects from Indian specific case further.
Well, you basically integrate that into your teaching. So when we are teaching something in a couple of weeks, you can show that what is the practical impact on the society. And that will be important, as in fact, we should do that often because everyone as a student should know that why they are studying it and what would be the final impact if I learn this thing in my class. And you, or as a teacher, will be the one who will be putting in the context of India specific cases. There was another question earlier, which is about pandemic situation.
Yes.
And I think, again, in my personal opinion, the interaction that we have in person, that cannot be replaced with online, even with all the tools, new tools that we have. And as much as possible, and as soon as we change it, after the pandemic, we should go back to the in person. But there are some advantages. So if whatever we have learned of online teaching, we can keep it hybrid once a week if it's needed, because of flexibility and because of, every learner or student is different kind. And we all know that they have different personality too. And we need to capture that, some with, some flourish in class and some even online. Because they're more, their personality is that kind that they would like to be on the, basically behind the scene and more comfortable in asking question, while in class they feel not much comfortable in asking question. So mixing those might help in capturing engagement of those kind of students.
So I think yes. I think there's no more question now. So thank you, sir. Thank you very much for your presence and for your valuable time. So Divya, can you conclude, please?
Yes, sir. Thank you, Dr. Biplab, sir, and Dr. Anurag, sir, for the valuable information in academic sector and highlighting the key areas of focus for enhancing one's skill sets. Thank you, sirs.
Thank you, sir. Thank you very much.
Thank you for the invitation.
This is our pleasure. Thank you, sir.
Yeah, thank you, Dr. Biplab and Dr. Anurag.
So Professor Akshay sir has joined for our next session, and that is basically student professional development with respect to IEEE. So Professor R.K. Singh have also joined. Anant Singh, yeah. Namaste, sir. How are you?
Yeah, good evening. Namaste. Yeah, doing good.
And I'm sorry for some miscommunication.
Yeah.
So still I'm outside Jaipur and I'm coordinating from outside. I'm in Bharatpur right now. So because of some...
You are doing great, whatever, and wherever you
sorry,
are.
Sir.
Yeah.
So that...
so hello to... I can see Anurag sir is there, Biplab sir is. Namaste, both of you.
Prasanna, you are Prasanna have also joined. And
Yeah,
Anant
hello.
Singh is
Can you
also
hear
joined.
me?
Yes.
Yeah, hello.
You all,
Okay.
yeah.
Good
So
evening.
this is a kind of panel discussion type thing. I mean, for our young professionals. So, Divya, can you please welcome all dignitaries?
Yes, sir. For the students and young professional development section,
Yeah, your voice is, there is some problem in your voice.
So now it's audible.
Some issue is there still. I mean, this is something I'm feeling, or other people are also. Naveen, what about you?
I think we are also like, you're getting the same thing. Yeah.
Yeah, we are not able
Okay,
to
okay.
hear properly. Yeah.
Yeah. So Divya, just check once, please.
Is it audible now?
Yeah,
Yes.
it is better.
Okay, sir. Shall I start?
Yeah, please.
For the students and young professional development session, we have Dr. Rajeev Kumar Singh, sir, Dr. Prasanna Rajagopal, sir, Mr. Anant Kumar Singh, sir, Dr. Akshay Kumar Rathore, sir. Dr. Rajeev Kumar Singh is an associate professor, Department of Electrical Engineering, IIT BHU. He received his master's in electrical machines and drives from IIT BHU and PhD.
Again, Divya, is it okay?
The voice is lost, Divya.
Yeah.
He received.
Yeah, Divya, again, there is a problem. Naveen, can you see? Can you look into the problem, please? Naveen?
So is it not audible even now?
Yeah, it's okay. Now it's coming. But in between, some problem was there.
There's very heavy downpour here. That's why.
Okay.
Okay, so
Okay.
shall I start from Dr. Prasanna Rajagopal sir's introduction?
Yeah. Start, please.
Dr. Prasanna Rajagopal sir, he has received the BE degree in Electrical and Electronics Engineering from the National Institute of Technology, Karnataka, Surathkal, India, and PhD degree Power Electronics and Alternate Energy Conversion from Indian Institute of Science, Bangalore, India. His research interests mainly include high frequency soft switching power converter, hybrid energy management in the field of alternate energy sources. Mr. Anant Kumar Singh, a senior motor control engineer at Halla, Mechatronics, USA. He received his master's degree in power electronics and energy systems at the University of Texas at Dallas. He is also pursuing a PhD at the University of Houston. His research interests include low voltage and high voltage automotive applications and torque ripple modeling. We also have Dr. Akshay Kumar Rathore, sir, who is currently an associate professor at the Department of Electrical and Computer Engineering from Conway University, Canada. His research interests include current-fed converters and multi-level converters. I invite all our honorary dignitaries to start the session.
Yeah.
Yeah, that's okay. So as a moderator, I will take over from now, and let's start. I mean, first of all, thank you very much, Dr. Rajeev, Dr. Prasanna, and Mr. Anant Singh, who has taken time for this event, and we have 92 participants. So this we organized every year, basically, sometimes through conferences in USA as well as India. In India, we do in ITech and PEDES, PACE-GRI. And this time, this is a Spark event, which is a MHRD or Government of India event, just to give you a brief. And so I will request each of you to give a brief 10 minutes of presentation. I mean, it need not to be in the PPT format or just a talk, and then followed by the questions and answers that audience may have, the students, scholars, and young professional may have. Generally, we start with the experienced people to, and coming back to younger one. Since this is a student and young professional program, let's start the reverse way. So I start with Anant Singh this time. Anant, you are mute. Just unmute and start.
Yeah, sorry. So I thought like we go with seniors first, not with young people first, but it's okay. All right. Okay. So I can kind of start. So is it okay, Akshay sir, if I like basically share my screen for a second?
Yes, you can. Yes.
Okay.
You have access here.
Hello everyone. First of all, I would like to start off by saying thank you to the entire Spark committee and specifically Dr. Aksharator for basically giving me the opportunity to kind of share my experiences with whatever I've done so far. Basically, I will be just going with going with my experiences and sharing what I've learned with whatever journey I've had so far. So to start off, like I'm currently working as a senior motor controls engineer at Halla Mechatronics in Michigan, USA. And I'm also like a part-time PhD student at University of Houston. And currently I'm also acting as the virtual platform chair for the IEEE ECC conference that's going to happen actually in October. At the same time, I'm also an active member of several IEEE committees because that's one way of me keeping myself engaged with all the IEEE activities as they happen. So overall, I have basically, okay. So yeah, overall, I have more than 7 years of experience in the automotive and PV industry. So I'll kind of start like by just putting an engineer lives in a graph. And it's kind of a funny story. I thought about this graph in like back in like the year of 2013, 2014, when all these advertisements about Teslas, like, you know, do you feel the torque? Do you feel the torque? That thing was going around. And one of my professors was really angry or like one not so happy with such statements. And he kind of drew this graph on the whiteboard, and he was basically explaining that this is not really a comparison. So if I ask like basically most of the people in the audience to kind of choose between like you know, a EV vehicle and a regular gasoline vehicle, I think most of the people are going to choose like the EV vehicle like from a performance viewpoint, because you know, you get the thrill of acceleration when you're going from 0 to 60 like in less than 3 seconds or something. So that is something that kind of attracts everyone. And the technical reason for basically like that performance is the electric vehicles. They are like using electric motors that can give you torque instantaneously at basically at 0 speed. But with regular gasoline engines, it's kind of, you have to build up the RPM before you start getting the torque. So when you're stepping on the gas pedal, it's expected like with EVs, like you're going to get like the torque instantaneously. So I took this graph and I kind of just changed the axis for basically relating to the engineers. So the y-axis, you can kind of replace the torque with enlightenment or passion, and like the x-axis, you can replace with the number of years. So unfortunately, with most of the engineers, we kind of tend to follow the ICE engine path. Basically, as in when we start the engineering, we have basically zero enlightenment of what we are trying to do, or we are not passionate about what we are trying to get into. And as the number of years kind of increase in your engineering, that's when your enlightenment or your passion kind for your like particular subject that you have chosen, it kind of increases. By the time you get to a job, you realize that, okay, you could have learned better, you could have done a lot of things better. And you're at kind of the peak of enlightenment if you get married. Now, the drop that you're seeing basically in the torque or the IC engine is basically a drop in passion when you are saturated with your job. Means when you do the same thing over and over every single day, you kind of tend to lose the kick of it. So what I would like to share basically at this point is that, okay, how do I keep my torque constant or consistent from the get-go? Means assuming that we are all students, what is that we could do right now at this very moment to kind of make our future career like a little bit better? So to basically, if I were to draw a path to industry, like in an ideal sense, from where we are and how do I get to my dream job, this is how I'm going to basically put it. So the very first thing is, like, whenever we are starting off the engineering. You have to start off by choosing a branch that at least excites you. You should be passionate about it, in the sense you don't have to know the technical details of the branch that you are choosing. You just have to have some broad interest. Hey, I just got to do mechanical, or I got to do electrical. Some broad sense should be there. You cannot just choose something that your neighbor chose, or just because like your some XYZ friend chose. It's not about that. You just need to start with something that you really like. Then basically during the entire engineering course, you have to basically keep a focus on fundamentals. And I want to kind of emphasize on this, because this is something that everybody would have kind of heard several times. When I say fundamentals, it's basically like every course that you're learning, like the basics course, 101 course, these things are the things that you're going to miss when you start your first job. You'll be thinking, oh yeah, I learned about it, but I don't remember it. And when you're learning it in the course, you'll be thinking like, oh, this is something, who is going to use that? In the sense, somebody is going to tell me like a better way of doing it. I really don't need to like know the fundamentals. So, and college is the only time where you will be learning this, like in where you will have a lot of time to kind of learn this. So you kind of need to focus on that. And then basically we are learning like so many subjects. We really don't have any interest in what is going on because you cannot relate to anything. Means you learn about Fourier series, you learn about like Laplace transforms, and you are like, why am I doing this? And at that point, it is really important to kind of try to know with whatever you're learning, how to relate it to practical applications. And the best way of doing it is just like go on Google and find where to use all these things that you are learning. And you'll be surprised that every small thing that you use is kind of so much tied to all these small rules that have been made by us, like in the older generations, that are still like very important. And at the same time, you need to, when you're in college, you need to focus on curricular activities, because the reason why I say that is like in addition to engineering and the knowledge that you're gaining in engineering, aptitude and logical thinking is something that you're not going to get from books. Even like how you communicate with individuals or how you basically present yourself, that is something that you're going to get out of the books. And that's where engaging yourself outside the like bookish activities is a must if you need to even become a better engineer. And it doesn't matter what like fest you're participating in. You just need to basically get out and like basically get involved with the world more. Now, when you get like towards the end of your engineering, or towards the last 2 years of engineering, that is the time where you need to like try to find some internships. And when I say internships, because you need to prepare yourself in order to like kind of like getting into the industry. And that is the time where if you want to distinguish yourself from others, the internships play a better role. And the other thing is, this is the time where the IEEE role comes in. So IEEE organization like makes your connections with so many people, like within the industry, outside the industry, academia, everything. You will find lots and lots of people in the IEEE committee. And that is the time where you will realize that why these connections are important and why do I need to participate in all these IEEE activities. And even if you're not able to like, let's say, get internships, you can at least try to like choose a research work that is like related with your focus area. It need not be, you don't need to like choose a project that is like easy to do because you want to spend like the last 6 months or 1 year of your graduation, for trying to do some easy project and just like getting that degree and getting off the college. Just try to do some research work, at least that is like, that is at least relatable to you. Okay. And when it comes to jobs, sorry, I kind of moved this. When it comes to job, I really hope that people stop like relying on conventional methods of getting jobs. When I say the conventional methods, it's basically, I'm talking about like, you don't need to wait for the companies to kind of come to your campus and then you will go sit in the campus and then give an interview and then hope to get selected. Because that's not the way that's going to work right now. You need to kind of explore around. And when I say explore around, where are you going to find all these people that are within the industry or could be your next potential employer? These could be like, IEEE activities. You could be basically like trying to get in touch with people like over LinkedIn. You need to use all these modes that have been that have actually basically rose in the last few years even further. And right now, since we are like doing things online, we better know how to use all these tools and how to involve ourselves in more and more activities, get in touch with more and more professionals, so that when it comes to like just getting one job interview, you can basically use your connection to get that one job interview, and everything rest is basically going to be just dependent on your knowledge. And during this entire job process, because it's like really it takes a lot of energy, it is very depressing sometimes. You need to keep a positive attitude, because getting a job is not going to be easy, and that is the time you need to basically do that extra step that is going to differentiate you from the rest of the crowd. So if you hear a bunch of no's, or if you hear like no replies from your connections or anything, just be prepared for it, because you don't know what's happening on the other side. So that's kind of about jobs. And now, assuming that you got into industry, now that's where for your passion to not drop, that I showed in the first slide, the very first thing that you need to find in a job is to make sure that you are continuously learning in your job. You're not just like going to the office morning 9 o'clock and trying to like get out of the office at 5. That is not going to work, and that is not going to make you happy. You need to continuously learn it. You need to basically diversify. While you're in the company, try to involve with more and more like sections that are within the company, so that you can learn more about the product that you're working on. That gives you like more thrill, and also gives you more knowledge and intuition of where and how you're contributing. And also keep a professional attitude when it comes to work, in the sense that if you are not learning, or if something is not falling within what you signed up for, you can always look for other options. It's more of about like what you develop and what are you developing personally, and how you're developing yourself, or how you're motivating yourself. That's what should be your ideal job, not something that just pays you and you are trying to stick with it. And finally, while you're having job, that is the time, you need to close this loop, right? So you need to get like involved with this IEEE societies, because remember that in the first year of your engineering, you were trying to like get connected with some of the IEEE members. So you better become one of those society members and like engage all these academic institutions with research projects. It could be from industry, or you could connect these students to some other people that you know professionally. So all that you have to basically do in order to like be useful to the next generation. And at the same time, it is particularly important that you help students as much as you can, because you have been on the other side. I've been on the other side, and a lot of people have helped me to get where I am. So I would really appreciate if everybody does that. And so just to not make it boring, like at every success, like every step in engineering or job or anything that you are doing in your life, you need to basically like stop for a bit and enjoy that moment, because as you get like towards more and more professional world, you will be having like kind of a little bit less people to enjoy with. So you need to enjoy it every step. You need to basically enjoy with all the colleagues that you have, make some good memories, because they are basically the positive energy that flows within you. And if you do fail, that's the time you need to actually even enjoy furthermore, because at that time you are basically learning something that you could have, that you could not have learned by just doing that foolish step or whatever it is. So at every step, just enjoy the life as and it comes. And just as a last slide, I want to kind of like draw a distinction between industry work and academic research, because I'm particularly like more into industry work, and for some people academic research might sound more thrill. And I'm just like, in my opinion, I'm just giving like 3 major differences between these two with whatever I've learned and whatever I've been able to understand. So for industry work, the objective is very simple. You have been given a set of requirements. You basically fulfill that set of requirements with minimal cost, and that's it. And now if a lot of people are basically meeting up that set of requirements, then the market is basically going to create a new set of requirements which will be more stringent. That might like basically ask you to move to a new technology, and that is the only time that you will move to new technology. But cost is basically the major factor. But when it comes to academic research, the end objective is not to make something like, that is cheap. The end objective is to basically make something that is novel, that is going to drive the next gen of products, and that is basically something new that has not happened before. That's what academic research is about. And when it comes to like industry engineer, whenever he's making choices, let's say I'm like very much like passionate about automotive. So whenever if I'm like selecting a part, or if I'm selecting a single IC also, I have to think of like what is the cost, what is the technology this IC is using, what is going to be the safety, what is going to be the reliability, will it adhere to all these different standards that we have. All these different things I have to think before I can use like one small product in my entire let's say whatever product that I have. But for academic research, you don't have to think about all those things. Like if you're choosing a sensor, you just choose like whatever you get from the market, because at that time your objective is not to like make the product. Your objective is to prove that new or novel technology that you have come up with. And finally, for people like me, my satisfaction is like seeing something in the hands of a customer that I've worked on. That is kind of gives me the thrill of what I'm doing. But for academic research, you should be basically having the thrill that whenever you are working on some novel method or technology, you have basically paved the way for the next generation of project that might be in the hands of customer, not like in the next 1 year, but at least next 5 years or 6 years. So it's basically what thrills you more. And where if you're some kind of person like me who wants to see something like right now, then then industry will be like basically a go for you. But if you're trying to like basically just work on something novel, something without like a strict time requirement, then academic research should be the way to go. So that is basically the end of whatever I wanted to share with everybody. Again, thank you for basically the entire committee for giving me this opportunity. And I think I can take questions now, Dr. Akshay, or maybe after everybody's done.
Yeah, at last.
Okay, all right.
Prasanna can proceed.
Yeah, okay. Let me share my screen. So are you able to see my screen?
Yes.
Okay. Yeah, thanks a lot for providing this opportunity to meet with all young students and young faculties. So thanks, Anant, for coming presenting before me. I think you covered most of the thing, which is like I aligned with what I'm going to present today. So yeah, just to give, today I'm going to like focus more on what I have done so far, and what are my experience and what I have learned from those throughout my career. So so myself, Prasanna, so I'm currently applications engineer at Texas Instruments. So I am within gallium nitride product line. So I basically I'm based out in Dallas, Texas, USA, and so we basically support all the customer challenges and customer issues, those who are currently using gallium nitride, or those who are trying to move from silicon or silicon carbide to gallium nitride. So we basically try to come up with new solutions and help them in solving their problem. So yeah, I'll go through those in next slide. So I just want to start with my background. So I am born and brought up in a small town called Udupi. So it's basically coastal Karnataka. There's a small town called Udupi, and you must have heard that it's famous for vegetarian restaurants. Point is, you could be coming from any background or any like a small village, but that never stops you from achieving what you would like to do. So yeah, I think the main thing is because of like the internet advancement. You see, like you have access to everything, and you have this is one of the examples. You have like this online panel discussion where you are able to meet someone from USA and someone from Canada. So this is something that we never had. So this is what I see like a advancement in this technology. So, and I did my engineering from MNIT Kesuratpal in electrical and electronics. So what I have learned during those days is, so initially, we have like all the courses from different branches in our first year, right? So we used to like tell why do we have to learn from if you're an electrical engineer, why do you have to learn from mechanical, civil, or some other area? But now I see the value of that when I am here. So those are some of the things you basically need to have as a basic understanding about mechanical design. For example, if you're an electrical designer or electronic appliance designer, you need to have idea about how the mechanical would be, how the thermal, all those things. It's not only about learning only one. You should not be like focused on one area. So you basically have to learn everything, and you should know basics of everything. That's what I would like to say. And we had like a lots of electrical courses. That's basically what is a foundation for if you're planning to go in research or industry. Those are some of the like a basic foundation in your career. And it also gives you like a gives you direction on what exactly your passion is, where would you like to go. So within electrical or electronics, you have so many areas, and it's equally like important to dive within yourself and see what's your passion and where would you like to spend your rest of your career. So I think that's more important, like whether you'd like to go with in VLSI or power electronics or coding or whatever you select, you should have passion. Then that basically enlightens, and that gives you like the 100% out of you. I think it matches with what Anant was showing on the graph. So, and yeah, I did not go for campus placement because I was sure that I would like to continue my education and would like to learn more on these areas. So, so after that, I joined ISC Bangalore. It's 2006, so it's almost 15 years back. Time just flies. Yeah, I was in formerly called as Center for Electronic Design and Technology. So that's one of the like a very unique departments in I would say in India, or maybe in entire world, which has which basically focuses on the product development. So it's not only like you design the circuit and leave it. It's more about like how do you like design a product. So we had like a lots of interesting and coursework there. So initially, first 6 months, I was I spent as a project assistant. I was working on a couple of projects in the lab. So that time I got a like a closer understanding of what exactly it's research. So what my colleagues or my lab mates are doing, how they are doing, and where do they find passion, and where do they find enjoyment in their work. So that made me decided to go for direct PhD. I was initially thinking of doing masters, then I since I understood the research fun, I decided to go with the direct PhD. And so what I have done during 3.5-4 years in my time in IS is so there we used to have courses which are similar to what I have learned in BE. It's a similar like power electronics or circuit design, but it's much more deeper in the sense in engineering you will be learning maybe in a surface level. But when it comes to masters or PhD, you will be going much more deeper and trying to make your understanding in the subject much stronger and better. We used to have coffee breaks 2 days in a day every day. So we used to have a continuous discussion with it used to be a very long, sometimes 1.5 hours discussion with the professors, students, other students. So you get to learn, share your ideas, share your problems, and also understand what others are doing, what how they are basically coming up with a solution to their problem. So it's basically giving you multi-dimension to your thinking. So that basically helped me in going out of what you are currently your background is. So for my PhD work, I basically selected solar thermal system based cooking. So it's a completely different. There's no power electronics in that. So I was working in power electronics lab, but my topic was completely different. So I basically took courses from mechanical engineering. I took thermodynamics, heat transfer, all those courses. So that's a good thing in these IIT and ISC, where there is no boundary. So you could basically go and sit in any of the courses, any of the department subjects. So that gives you there is no particular domain such for research. So you can you are open to work on any area. So what I would like to tell all students is don't make your mind fixed to one area. So when you are in higher education, you can just be open to different areas, domains. There is nothing like one domain. So it's all multi-dimensional, and you basically come up with some ideas from different domains. So as I was working on the solar system, I had to come up with a very low flow rate measuring a flow meter. So there was nothing available in the market. So what since I come from electrical background, I had very I took some analogy from electrical circuit, where how we basically measure current. So I took that analogy and brought it to the flow measurement, and it was a great idea, and we had patented that one. So what I would like to say is when you go from electrical background to some other background, you may get a different idea, which is never thought by a mechanical engineer or other engineer, because they always think of in same direction what they have learned, and they try to apply same direction. But when you come from a different background, you basically have a different view, and it may maybe spark a light. So and I'd like to say what my professor used to say, that thesis and publication are byproduct of your research, and you just focus on what you'd like to what are the challenges and how you basically solve that. And once you have a solution, then that automatically becomes your thesis or publication. So that's a byproduct. And the PhD is not like the end of your learning. So this is the beginning. So once you are done your PhD, you are like matured enough to like go and tackle any problem, and you can basically solve, understand the problem in any domain, and you'll be able to like give a solution. So I think that's what I have learned. And I did like 2 postdocs, one in NUS Singapore and another one in University of Texas at Dallas. So there I have worked more on power electronics, high frequency fuel cell converters, and grid integration of solar and battery. Those those are some of the work I have done. And another thing I have done is like a developing lab. So that gives you more insight onto what equipments are needed for like a development. And if you're teaching and developing a lab for a student, then how do you like make it more interactive, and so that kids, students can learn, and that gives them like a more motivation to in the subject. And parallelly, I was mentoring students, masters, PhD students. So that gives you like a opportunity to transfer your knowledge, and also you also get to like involve in their hardware project and debug. And that also gives you more. It's kind of bidirectional knowledge flow, I would say. You also learn at the same time. And so yeah, and the thing is, in academy, we try to, as Anant mentioned, we try to build a hardware that just to prove the concept, and not going into details of cost optimization or other things about the implementation in terms of like a product. So, and I think what I have learned is you have to be updated on what where industry is going when you are doing your research, and that would be much more impactful and useful. And and also university and industry should go hand in hand. It should not. They are like 2 parallel lines. So it should university should be focusing more on what industry needs, and industry should also take what university is doing and implement in their product. So, and I joined like a Texas Instruments like 5 years back, and initially I was with the grid infrastructure team. I was again focusing more on the power system protection and distribution. And currently I'm with the GAN team. So what I have learned so far is like you have to basically learn what are the customer challenges and try to assist them coming up with a solution that basically helps industry to move forward. And also, what we do is innovative ways of implementing subsystem for a specific application, for example, solar inverter or protection relay or circuit breaker, using existing semiconductor we have in the market. And if we see some gaps in ICs, we basically also come up with new ideas to develop a next generation of semiconductor parts that basically helps in, for example, integration of parts or modules that basically helps in reducing the size of form factor of the power converters. And it also like gives opportunity to like propose new architectures to industry. And what I have learned in these years is you are basically directly working with the product developers. Those are like customers to TI. So we basically work very close to the customers, and we know what we work is coming on to like a product in maybe 1 or 2 years. We might, when we see like oh, that's a product, so we have like a part in our Tesla or in our laptop or iPhone. So that gives us more satisfaction that, oh, we have worked something that's really useful, and that's something used by a common man. and it also gives like a better understanding of where industry is heading and what their requirements and where they're heading, like a next 5 or 10 years, what would be like a next generation solution. So you basically work towards that also. And so in academy, we just focus on making it work, and whereas in the industry, it's more about like optimizing cost, size, environment. When I say environment, it has to work in like a, for example, it's automotive, then it has to work in different EMI, EMC standards, then vibrations, such as, so and so. It gives you much more dimension to your problem. So it's a multi-dimensional optimization issue. And yeah, I just want to conclude with the final thoughts: be limitless and be fearless. There is no boundary for learning and new ideas, whether you are in academy or industry, and continuous contribution. So try to solve in day-to-day life. You look at some of the like critical challenges and try to solve. That automatically gives you like a publication or patent. So don't focus on publication patents. Once you like try to solve, it automatically follows the fruit of your research or development. And last but not least, share your experience and knowledge. Try to like share with your younger your like students or your colleagues. So that gives you like a bi-directional knowledge flow. Yeah, thanks a lot for providing me this opportunity. Sorry, I went a few minutes over the time.
Yeah, that's fine. It is the last event today, so we can go longer. And now I request Dr. Rajeev Singh, my close friend, my colleague, my fellow, to speak. And he's coming from academia, so he will give different perspective now.
So thank you, Akshay. Thank you, Dr. Arun, for giving me this opportunity to share my thoughts. I belong to academia, as Akshay said. He's a friend. He's his colleague. I mean, and it's always a pleasure to share my views before such a successful colleague of mine, Professor Akshay Rathod. So yeah, I mean, students, colleagues, very good evening to you all. Let me share my screen. So is my screen visible?
Yes.
Yes. Okay. So now our previous two speakers have actually shared their journey, how they have actually maneuvered their professional career right from their student life till that to the point they are working now. Now I'll take a different stance basically. And me, actually, I belong to academia and I do research in the power electronics. So I'll try to emphasize, the research and innovation in power energy and the role of power electronics into that. And what I always feel that it is an era of power electronics. So I'm making this statement, and I'll try to justify my statement in my presentation. So whenever I used to get a chance to interact with an audience, whenever I used to get a chance to take a class in my initial classes, in the first interaction itself, I used to make out this statement that yes, this is an era of power electronics. So for students, basically, I'd like to say that, yeah, you can think of, your career in the field of power electronics. So if, in order to justify my statement, I'll cover some of the things here very quickly, since I have been allotted only 10 minutes. So though it is very difficult for an academician or a professor to compile his thought or her thought in 10 minutes, because we used to, of the situation where we used to speak a lot about the things. So I'll try to give the glimpse of what basically we know about this power processor. What do we mean by power processor? And then what is the role of power processor in electronics, electrical, and computer science engineering? And because of that, this power processor has become so popular, so powerful tool. Without power processor, without power electronics interface, you cannot think of any new development or circuit level development in the field of electrical, electronics, or computer science engineering. When I was a kid, actually, I used to heard the statement from Tata's that they say that you can hardly move 10 meters without encountering a Tata product, right? And I similar kind of a statement I'll make out here, that you cannot think of any new development in the field of electrical, electronics, or computer science engineering without having some involvement or other of power electronics, right? And then I'll try to give some of the research areas where we as a power electronics student or researcher can chip in and contribute. Then some of the application areas, future aspects, and of course, I'll try to conclude. So just look at this fundamental block diagram. I know, I mean, you all might have gone through this basic block diagram at certain point in time of your student life or in your professional life. So if you just look at this basic, block diagram, it tells the entire story. There is a load, there is a source, and wherever in which what corner you are of the world you are sitting in, just look around yourself. The type of electrical load is there, around you. You will find that there are many loads that run on 19 volt DC. There are loads that run on 5 volt DC. There are load that run at 110 volt 60 hertz AC. There are loads in India 230 volt 50 hertz AC. The demand has gone up like anything in the modern world, right? And if you look at the source, the available resources, so either you will have the AC source, grid power, right, or you will have a DC source. Now, who is going to take care of that power processing, right? In order to process the raw available input, right, according to the load demand. So there is a load that runs at a high frequency DC. There is a load that runs at the 9 frequency AC, etc., etc. So just around ourselves itself, we can find n number of loads with n number of different requirements, but the input is fixed. So there is a development or a technology in between that says, hey, just give me the input available to you. I can process that available input according to the need of the load, right? Just forget about it. Just tell me what you need. Just tell me what you have, right? I am here to process that supply according to the load demand. And that is exactly why, just look at the way how basically powerful power electronics interface has become in the modern world applications, right? You have got a technology available at your hand that is saying you that, okay, irrespective of the available input, you just tell me the load demand, I'll process that power. And not only process that power, I can regulate that power as well. I can regulate that variable. I can regulate that voltage, current, etc. And not only I can regulate, I can give you significant stability as well. So just look at I'll keep on justifying my statement why this is an era of power electronics if you belong to electrical engineering or electronics engineering or computer science engineering. Anant has just, quite a few minutes back, he said that you choose a branch that excites you. Right. I'll actually add up one more line into it and say that, okay, you choose a branch and make it exciting, right? Whatever branch you choose, make it exciting. Come on, life is not, it will never always happen that whatever you want, it will come to you. In fact, whatever is coming to you, make it exciting. So that is what, power electronics interface is there, that is kind of looking after the power processing. It is looking after the regulation of the supply. It is looking after the significant adequate stability of the entire system. And that is exactly why, it has become such a powerful technology in the modern world. Now, just look at that. As I said, I have perhaps spoken about this slide that yes, you have got a source, either AC or DC, and just look at the load, the type of load that you have to cater. One may require AC, DC, high frequency DC, variable DC, this, that, everything. And the component that basically takes care of is the power converter and if you just further unlayer the power electronics interface, you'll find that, okay, there is a controller also that will be playing its role. and the elements that will be involved in actually development of these power processors, right? So you'll find that, okay, there are three elements, two switches, switches, not two, switches, and two passive components. One is electromagnetic component, another is electrostatic component. Switches, of course, they will not be mechanical switches. They will be, semiconductor switches, wide bandgap, high devices, etc. So modern switches, right? So this power converter basically is made up of these three simple elements. And if you look at the controller elements, you will also, again, you will find that, okay, if you go further into deep details, actually, previous speakers are there from the industry. They might be, knowing all these things that, what from these ICs are made up of, how these controllers are basically, they are being designed, etc., etc. These are the elements basically that are involved in the development of power electronics interface. And this gives you again the type of load demand that you have to, supply, just irrespective of the available input. So you pick up any modern application. This is for your contemplation. If you have any otherwise thought comes in your mind, just you can drop me an email. We can have a further detailed discussion afterwards, offline as well. But you just pick up any single development in the field of in the field of electrical electronics and computer science engineering, you will find that power electronics is there and it is playing its role. Without the integration of power electronics, you cannot think of any modern world development, right? So, to conclude with what I will say that, okay, yes, the power processor is there basically that processes the available input according to the load demand. It basically, gives regulated voltage and current, and it ensures enough stability to the system. If I say stability, I always, emphasize on the small signal dynamic changes, right? Because large signal dynamic disturbances comes under the category of the fault, and for those things, you need to employ a certain different kind of things with the system, right? So having said this, now I'll actually give you certain application areas in order to justify my statement furthermore, right? So just look at it. Okay. Before I move on, see, we are researchers, so we cannot actually come out of that domain. We always, our lab is our entire life. So my kids and this family says that is your main home and this is your hotel room, because we used to spend more time in the lab and less time at the home. So they say that why have you have come home? So they give him food, he will sleep and again go back to his main home, right? He's back to his hotel room. So that is why, let me give you a bit of a glimpse where basically we can chip in as a power electronics student. So if you again go back to this basic block diagram of a power electronics interface, you will find that, okay, it has got a converter and it has got a controller. So, where you can come in, we can carry out, researches and contribute something as far as the converter aspect of the power processor is concerned. So we can propose new things. And that's what people are doing all across the world. Irrespective of which lab you belong to. If you are active in power electronics research, you are doing either research on a converter part, or you are doing some research on a controller part, right? Or you are coming up a integration of both these two together. You will not find anything else than these three. So you just see, things are very small but very big. You have to be very careful about the things, about if you are saying that you are really proposing something new. So having said all these, let me quickly run through these things. So if you look at the microgrid application, electric vehicle is the theme of this particular course. Just think on, I was just actually going through the brochure. Actually, Dr. Arun had sent me, even Akshay actually had sent me a few days back. So you will just have a look at that brochure. You will not find anything other than power electronics. So that means if you are talking about electric vehicle, right? Just look at the role of a power electronics, how much, prominent, significant role that power electronics plays as far as the development of this electric vehicle subsystem, infrastructure, everything is concerned. Of course, other interdisciplinary branch, technologies are also there. So you can say that, you can very well argue that, okay, material science has its role, chemical engineering has its role, ceramics engineering has its role, etc., etc. But predominantly, you can say that it is power electronics basically that is playing its role. And because of that, we all are here. We are earning our bread and butter, right? So just, let me quickly go through, move on. Akshay, just ping me if I'm taking more time. Sorry, I'm not. So, yeah, so let me, I will not touch upon these things. Perhaps one very, very fundamental thing that I would like to share with you all here, that, okay, actually, see, this is basically the definition of power electronics Professor Philip T. Crane has given in his book, Elements of Power Electronics. I just love this definition. So just look at, he said that, okay, you make a triangle, right, in which electronics and devices are there, systems and control is there, power and energy is there. Take a median of it and make a new, triangle. So whatever will be there in the inner triangle, that will be power electronics. So that power electronics basically has the involvement of electronics and devices, circuits, magnetics, power semiconductors. It will have the systems and control. It will have, energy processing, power supplies, motors and drives. So everything, just think on, and you will find that, everything is, has got some role or other in, as far as the definition of power electronics. So I will actually, say to this, my young students and professionals, that you can think of, building your career in the field of power electronics. It is very, very, strong area at least in the modern world now, the world in which we are living in presently, right? You'll have a lots of scope of your, strong, prominent career in the field of power electronics, right? And see, I belong to electrical engineering. So this is very, I love this slide. Why? I'll give the justification. So just see, there are four elements, right? Energy active elements. We know that what is energy active element, that basically has the virtue of giving energy by its own. You have got a passive element that cannot give energy by its own, but you can actually store energy and you can take it out whenever required. And the switches and load. I'm going to make two statements over here. And if you differ, please, drop me an email. I'll say that entire power electronics, circuit level power electronics basically revolves around these four components. You will not find any other component than these four. You will have energy active element, passive element, switches and loads. So if you can have the catch hold of these fundamentals of these four elements, you can say that, yeah, I know power electronics. Now I'm going to make one bigger statement. In fact, I would rather say that entire electrical engineering revolves around these four components. So your entire electrical engineering, believe me, just have a thought on it. Think about my statement, and if you find anything, any cross argument, just you drop me an email. I'll say that the entire circuit level electrical engineering revolves around these elements. So someone who is really interested to build up his career, in power electronics, he must have the catch hold of the fundamentals of these four elements, right? And yes, so nothing to conclude. What I will say, in fact, to my students, young professionals, said, yes, see, life is very beautiful. And I think Anant in his slides has said that you enjoy. So the first thing is, don't learn anything, learn how to enjoy, number one. So once you will learn how to enjoy, rest of the things will take care of itself, right? Whatever you will do, you will be very happy. Irrespective of whether you are in Texas, whether you are in Varanasi, whether you are in Jaipur, we all are happy people, right? So, and irrespective of whether you are in academia, whether you are in industry, whatever, you are doing. I have learned one poem, Akshay, I think you might be remembering also, कि वो क्या था, एक किंग था जो कि एक बोला गया कि एक ऐसे इंसान को जाके तुम खोज के लाओ जो कि सुखी है. तो उसके पूरे किंगडम में कोई इंसान नहीं मिला, बट एक फार्मर मिला. वो जो है फार्मर के पास अपर उसके पर, he was topless basically, right? And he was just plowing his field. So what happened? He was actually singing a song. So that soldiers of that king basically went to that particular guy and said that, okay, are you happy? Because they were finding out that who is happy in this kingdom. And nobody said that I'm happy, right? When the soldiers approached to that farmer, he said that I am absolutely happy. There is no problem in my life. He said, why? I am happy. There is nothing to worry about. Then he said that, okay, you are happy. Then क्या हुआ, वो किंग को पकड़ के ले आया वहाँ किंग के पास. बोले अरे ये तो सबसे सुखी इंसान है और इसके पास कुछ नहीं, इसके पास तो पहनने के लिए ऊपर के कपड़े नहीं है. ठीक है. So what I will say that, yeah, this is an art. So please be happy. I mean, you will be very successful. And I don't know whether my presentation actually was in line with the theme of this particular session. But yeah, thank you very much and wish you all the very best. And it is always a pleasure to, share the views with my best friend, and colleague Akshay is there. It's pleasure. Akshay, over to you.
Yeah, thank you, Rajeev. And now to audience, basically. So you can ask questions, technical, non-technical, and future related, careers related, and you can approach directly. I mean, you can tell the name whom you want to ask the question, or if it is a general question, then we can ask all three speakers to answer. So over to audience now, one by one, you can ask your queries, unmute yourself, introduce yourself and ask your query.
Hello. Good evening, sir.
Yes.
Sir, I would like to ask one question to Prasanna, sir, Texas. Yes. Sir, actually, a few days back, I have read this topic that Texas Instrument is using the piezoelectric something based of converter, which is having a very high frequency. Now, this gallium nitride we are also using, which is able to reduce the size of power electronics. I mean, DC converters, and this piezoelectric is also reducing the size of DC converter. So, can we compare that a converter which is using the DC, converter which is using the gallium nitride, and the another converter which is using this piezoelectric? So, which will be of lesser size?
So I think as far as I understand, piezoelectric is not a switch. So it's not
no,
a...
Sir, I mean, piezoelectric we can use in the transformer.
Yeah, it is basically a source for like it vibrates and generates oscillations. So it is not basically a switch. So when it comes to switch, you have like a silicon or silicon carbide or gallium nitride. Those are like a wide band gap materials that are used for switching in your power electronics. But I think the one you're saying is piezoelectric is like a source for your oscillation. So it can be used like a timer or some like a low type of like a high frequency generator, AC generator. So it's not like I don't think it is used for like a clock generation or like a high frequency signal generation. It's not like going to replace gallium nitride. I think those are completely two different topics, I guess.
Okay, so I mean, in a converter, can we use the gallium nitride switches and this piezo-based transformer, both?
I'm not sure. Maybe piezoelectric is those are used maybe for generating PWM. Maybe I'm not sure.
Yeah, piezoelectric is not a part of power conditioning unit. Piezoelectric, the one you are talking about, is basically the energy harvester. Okay, the purpose is to basically generate energy. It is just a source, energy harvester. After that, you need power conditioning, and power conditioning is done through the switches, and that Dr. Prasanna is mentioning that it can be done through silicon carbide or gallium nitride. So that is stage 2. Stage 1 is the source, which is your piezoelectric energy harvester, purpose of energy harvesting, like a transducer. Yeah, other questions? Yeah, audience can unmute and ask questions.
So, any questions from the audience side, please?
Hello, good evening, sir. Excuse me.
Yeah, please.
Sir, my name is Ravi Kumar. I would like to ask Akshay sir one question that what is the research challenge which to come up in like designing of EV chargers, sir? We are using the current fed bidirectional converter.
Mhm. Yeah, so actually the good part is that we all four can answer this question because Dr. Prasanna, Anant Singh, Rajeev Singh, we all are working on basically somehow EV charging. Dr. Anant, Mr. Anant did his masters on that. Dr. Prasanna worked on that. And myself, we are working on that. So we all will answer your question one by one, and I start with these two will be able to give perspective from industry side, and me and Rajiv can give perspective from academia side. Okay, so yeah, from my research experience, my students worked on a bidirectional EV charger system. The major challenge major challenge that I faced was basically optimizing the efficiency in reverse direction during regenerative braking, we can say, or we can say a V2G operation, whatever you want to say. In the reverse direction, optimizing efficiency, I got one challenge. And second challenge was basically the control stability. When we started designing the controller for the front end part, basically as a AC to DC. So we were able to do it. And when we design it, when we use the same controller for the reverse, it was a challenge. Then we have to modify it again and again. And then finally come to a controller who can work, who can show wide operating range stability in both the direction, G2V as well as V2G. And the first challenge, as I was said, was basically we optimize the efficiency for the charging part. When we do for V2G, it was somehow a bit lesser, not that optimized one. So from academia side, I faced these two challenges. So I hand over to Rajiv, and then we come to Anant and Prasanna.
Yes, so I mean, I'd like to add upon what Akshay has said. See, if you look at the entire charging infrastructure, you will observe that there are two kinds of chargers, right? One is onboard charger, another is offboard charger. So offboard charger basically comes under the category of DC fast charging basically, and onboard charger, they are AC charging, right? So what happens basically this, you plug the thing with AC charging station or with the home, thing, and then through electric vehicle supply equipment. So there is an interface between the onboard charger and this grid supply. There used to be a EVSE, electric vehicle supply equipment, and then the output of that electric vehicle supply equipment goes to the this onboard charging that is installed in the vehicle itself. So as far as the challenges, you're coming back to your original point that what are the different challenges associated with the EV charging infrastructure. So these offboard charging has different challenges, onboard charging have different challenges. So as Akshay has said, that optimizing the efficiency, right? Optimizing the power density, optimizing the cost basically. Because what happens if your onboard charger is costly, then your entire vehicle cost goes up. So these are one of certain challenges basically, and because of that you will find that many new kind of reconfigurable power processors are coming up basically, right? So those reconfigurable power processors, what they do basically in the charging mode, the same processor acts as a DC output, and in the propulsion mode, basically the same set of switches and passive components basically give rise to the DC to AC power conversion. So if I say basically as far as the challenges in the onboard charger is concerned, so I'll list down two, three challenges. One challenge that is associated with electric vehicle supply equipment is how to deal with the power line communication, because electric vehicle supply equipment need strong power line communication, number one. Number two, the onboard charging setup that is installed in the vehicle itself. So optimizing efficiency, cost, and power density, right? And then the battery management system, right? And the battery management system basically that gives the information about the remaining useful life of a battery, state of the charge of the battery, and any fault that has occurred or any impending fault. So these are the things that we have actually encountered as far as onboard charging is concerned. In the offboard charging, that is DC fast charging, so you need to pump a lot of current, heavy amount of current to the battery that bypasses, basically that does not need any onboard charging system. So you need to be very careful that or how much amount of the current that you are pumping in, the stability should be properly ensured, right? And you need to design your components, because let's say if you are saying that you'll be pumping some 200 amperes of current to the battery, so designing 200 amperes of DC output current for that particular purpose, you need to design a power converter. So those components, so those stress levels, etc., etc. These are the certain things that basically comes in as far as the challenges related to DC fast charging is concerned. So this is academia viewpoint. I invite my these industry people to comment on this. Or if you are satisfied, I mean, that is okay. We need not to go. I mean,
yeah, just one comment I would like to add in addition to what you both have mentioned. So another thing is, when it comes to industrial implementation, there is one more dimension, that's a functional safety. So that's very, very important. These are like going into all the vehicles. So functional safety is very critical. So it has to you have to make sure all the temperature, everything is within the limit, and it has to be tested at 60-degree ambient temperature. So in that condition, it should not go over the temperature. There should not be any failure. So those are some of the issues, challenges when it comes to implementation.
For me, I would add a completely different dimension to it, because I didn't tell what area I'm working on. So we are into all the automotive actuation equipments that are there within the car. We almost work on every one of it, and I'm actually thinking. So here, you all will be surprised that for the cost of the car that you are paying, and the cost that the target cost for basically making an inverter that will go into a production car is you will not be able to imagine the number. I cannot disclose the number, but I can basically do this comparison that if you try to go buy a silicon carbide module or an IGBT module for, let's say, 1200 volt, 600 amps or whatever power requirement that you are having, whatever is the cost of that module, you should basically make your entire system within that cost. So that is basically the first challenge. Okay, how do I make it? Because the problem is the industry is transitioning basically from, we had all these IGBTs and everything in the previous generation, which most of the present hybrid and EV vehicles use. And then we are transitioning to silicon carbide. Now, if you go and ask for any manufacturer for silicon carbide, unless and until you give them 4 to 5 years down the line that, hey, you are going to buy something from them, they are not going to give you a good cost. Now, if you, I don't know if anybody has watched Tesla Model 3 inverter video. It's basically a motor drive inverter. What they did is basically, instead of going for a module, they basically went for independent switches, small 30 amp switches, 1200 volt, 30 ampere switches. And they basically spread a lot of them across the PCB. Now they got two basic advantages with that. The first thing is now, because your area is kind of spread, then you have more area to, you have more ability to cool the entire set of switches. And also they were able to drive, still maintain the cost, maintain the target cost or whatsoever. And when it comes to basically, as everybody was saying, when you're pumping in so much of current and so much of power into the system, and at the same time you're also trying to make the power density higher, you're trying to squeeze the entire thing into much small and small. So any efficiency it has, it's going to have some amount of loss. How you take that loss out of the system, that is a very difficult area to kind of consider, because You have to like design your coolant system that can take the power, means the lost power that you're having out of the system and like keep your thing at the ambient temperature. The other thing which Prasanna was pointing out is like the safety. You're like half of the time what we are discussing is like or in our product the major thing is like, okay, what do you do if this thing fails? What do you do if this thing fails? Okay, you have to basically think of all these different conditions that are going to happen within the entire inverter, where you have to cover for all those cases. Like today, like the entire automotive industry is like, you do one fault, you should be still functional, at least partially functional. You do dual fault, then yeah, you can basically, your system can like shut down or whatever it can do. So safety, then cooling on top of everything that people over here said. And of course, like the cost is the major factor. Sorry, I've been talking cost because that's the challenge that we have been put like every single day. Like, okay, give me something that, you know, that is like a fraction of what you would be thinking, literally. So that was kind of my opinion on top of everybody's other valuable opinion.
He should be oversatisfied now. For one single question, 4 experts have answered. Yes.
Thank you very much, sir. Really inspiring to hear all of your experience. Really broadened our perspective on this area. Thank you so much.
Yes,
So one participant has one more question.
Yes.
Sir, it is for Anant Singh, sir. Sir, you have shown one graph at the starting between enlightenment versus the number of years. In that same graph, before the graph, there was a graph between speed and torque. How can it be possible at zero speed and zero torque? How can even machine start? That's the question from.
Okay. Yeah, actually, that's a great question. And Dr. R.K. Singh also like said over there, like the very ideal thing is that at the start of your career itself, when you basically are starting your engineering, that time itself, you're pretty clear of what you want to be. Unfortunately, with most of us, let's be frank about it, with most of us, we really don't know what we want to do, and only when we start knowing things, that's when we said, oh, I could have done this or I could have done this. So Dr. R.K. Singh like rightly said, make what you have as exciting, in the sense, let's say if you chose a branch, right, means now let's say if, I don't know, the audience over here, Dr. Singh, like Prasanna, everybody like talked about power electronics. Now you should not think that if you are in like some other domain that, oh, it's the end of the world and I'm in third year and I chose a branch that is like completely of no use. No, it's not like that. It's basically whatever domain you are choosing, just like find find some real products that are using it, and you will be like basically excited and like more and more you will find like more and more fun doing that particularly. And I think everybody said one thing in common. It doesn't matter what you choose. You also have to diversify. That whatever you chose, right? That's good. You are supposed to be good at that. But everything else that happens, let's say for electrical engineer, if you're doing things on mechanical engineering, or if you're taking projects from mechanical engineering, thinking from an electrical engineering perspective, that's totally fine. So if you just don't like refrain yourself to one single thing, that's when you will be like more motivated. But the point is to just keep motivated. Like Sundar Pichai like did his like bachelor's, I think, in like mechanical engineering, and he's like the Google CEO. So like I was reading about him whenever the things were flowing around. So you can just think, right, like why a mechanical engineering is like a CEO of like the world's best like software company whatsoever. So the point is, like, if you're passionate with whatever you are doing and you're like excited and happy about it, that is all that matters. Everything else is just going to be like following on that. And with engineering, the good thing is with engineering, you can easily find things that you can relate to. Anything that you are learning, any chapter that you take on the book, you will find something that you can relate to. So that's what is basically the initial motivation is what your initial torque is. And as long as you have motivation, you have the torque. So
I think we can close now because we have taken extra time of the speakers already, extra half an hour.
Yes, yes. Divya, if you don't have any questions, I think we can close the session.
Yeah, and you can also approach them through email always.
Yeah, yeah. All the speakers are available through email also.
Divya has some network issue.
Okay, Naveen, you can continue, please. You can close the session.
On behalf of Spark Committee, I would like to express a big thank you to all the dignitaries, Mr. Anant Singh, Dr. U R Prasanna, Dr. Rajeev Kumar Singh, and Dr. Akshay Kumar Rathore, sir, for their enlightening talk towards students and in professional development. I must mention deep sense of appreciation for Mr. Anant Singh and Dr. U R Prasanna for sharing their professional journey, and it must have been a great inspiration for all the participants in this session. Further, we are grateful to Dr. Rajeev sir for a brief note on research and innovation in power electronics domain. And finally, Dr. Akshay sir for being with us from the day the course has been started. We are very grateful for your words, sir. Thank you very much.
Thank you, sir. Thank you very much.
Thank you, MNIT Jaipur, and thank you, Arun, for hosting this.
Sir, this is my pleasure.
Sir, there is one screenshot. It will be better for all the
yes,
speakers.
yeah, photo, yeah, photo, yes, yes, yeah. Yeah, the audience can also turn their video on if they want to.
Audience
Yeah.
can start.
Audience, if they want, they can
on the
turn. Yeah.
video, please.
Yes, please.
All the audience. It will just take 2 minutes to move on to all the participants. Please turn on your video. Thank you very much, sir.
thank you.
Okay, thank you. Thanks for the
Thank you,
organizing
sir.
committee.
Thank you.
So, Akshay, may I sign out now? Akshay, you are muted.